data engineering industry is totally changed, and open table format is the biggest change that revolutionized the dynamics of the whole data engineering industry. All the big companies are extensively using open table formats, and all the other companies are following the same trend. And that is why you can expect lots of interview questions as well revolving around this area alone. But what's the best resource to master open table formats in 2025 that will cover all the conceptual knowledge plus the practical demonstration? So this 3 hours long video will cover everything you are looking for, right from the scratch, covering some fundamental concepts to the advanced industry level solutions with practical demonstrations of real-time scenarios, along with amazing optimization strategies that companies are looking for. This is your one-stop solution to master open table format and can help you to crack multiple offers in 2025. So, are you ready to learn and master open table format in 2025? And I know your answers. So let's get started. Happy Sunday, and what's up my data fam? What's going on? So today we're gonna talk about one of the most hottest topic, and it's none other than open table format. So basically, as we all know that our cute, beautiful data engineering domain is just growing rapidly, and there are like so many changes happening, like they are like crazy. Like you will just wait for 1 week and there'll be a new change, there'll be a new update. So here's your boy Anshalamba will be covering all the updates so that you will be all updated. And obviously you need to be updated in order to crack your data engineering interviews. And if I have used this word data engineering interviews, so let me just clarify this thing, bro. For data engineering interviews, I know a lot of things are important, but for now, by looking at current criteria and current scenarios, this is the most important area, open table formats. And let me tell you the reason why. Because you cannot perform any data engineering thing in the modern day or in the modern world without open table format. Without open table format, you cannot perform any data engineering solution. Trust me. Okay, what is this? Don't worry. This is just a basic question. What is this? We're gonna cover everything in the world of open table format, and you will master open table format, and you will actually feel the power of open table format after this particular session. Trust me, we're gonna cover like almost everything. And without delaying, I would just like to start the session, and just hit the subscribe button right now, because then you will be just hypnotized in the video. Because this topic is really good, this topic is really interesting, and you will actually feel that okay, you are understanding all the things. Because the thing is, now every industry is adapting open table formats. Okay, a lot of big companies have already adapted. Okay, so now they want data engineers who can efficiently work with open table formats. But where are the resources for it? We do not have much resources, bro. Just check, just go to your favorite channels and just go to your favorite platform. Just check, there are not much resources now. And if we do have some resources, they are just like introductory resources, like what is open table format, that's it. But you need to understand like how we can become a pro in open table format. Because if you just want to know what is open table format, you can just go to Google, you will get the definition, you will get some good blogs. But if you want to understand everything, then this channel is for you, and you will learn everything from scratch, because we do the real teaching, or let's say we actually provide the real knowledge that is required. Okay, so without delaying, let me just start with open table format. And I know this is a new word to you. Maybe like some of you would have already heard about this, but do not have like much deeper understanding. So let me just tell you what is that. And let me just welcome our new data family members who have officially joined my YouTube channel and have become verified data family members. So welcome everyone. And we have one more sheet here, we have some more people. So you all are welcome, and love you a lot for your support. And I know you guys really do support me a lot. So keep supporting, keep loving, and let's get started with this video. Let's actually start the process right from the beginning. Yes, right from the beginning. So we all know that earlier we just used to work with the structured data. Okay, only structured data. And what was the favorite hub to store the data which was in the structured format? You would say obviously SQL databases. Yes. And if you are a data engineer, what will be the favorite hub to store your structured data? You will say OLAP database, which is OLAP database, and which is also popular with the name called data warehouse. Make sense? Okay. So data warehouse was the favorite hub to store your structured data, which was in the form of tables, table format. Data was in the table format. Data was stored in the form of rows and columns. Everything was structured. Everything was structured. Okay. And this approach was really popular, and everything was going smoothly till till I would say 2000, till the year 2000. That's it. But after, we actually saw a great rise in big data. Okay, big data. This new player was actually growing rapidly, and this structured way of storing the data was not able to handle it, because big data was not just about like big in size. No, it can handle big volumes of data easily, but the actual reason was something else. It was other problems as well, such as variety, different varieties of data. That means we were having semi-structured data, we were having text files as well, we were having unstructured data as well, like images, videos, GIFs, everything. So now it was time to work with these data sets as well. Can you just store an image in SQL database? Can you store a text file? Can you store a semi-structured data? Can you? Okay. Then the other problem was velocity. Data was rapidly growing. Data was rapidly growing and rapidly changing as well. Let's say you ingested one data today, and just let's say tomorrow you are saying, hey, schema is changed. Now just change your pipelines. I would be like, bro, are you kidding me? I spent the whole month to build this pipeline. Now you are saying that just change it. Okay, let me change it. But again, after 2 days, you will say, hey, there's again a change. So actually, there were like so many problems that were like arising with the time, with the growth of big data. Then in the early 2000s, we actually launched something revolutionary. Okay, and we launched something called as data lake. Something called as data lake. And data lake was actually the solution for storing data in the form of semi-structured and unstructured as well. Okay, semi-structured and unstructured as well. So we were able to store all the data. How? Because this is just a kind of blob storage. Data lake is just like your blob storage where you can just dump your files. And data lake is so cheap as compared to your SQL databases. You can just save a lot of money. You can dump all the data and you can just perform all the stuff. Everything is perfect. Okay, and we are already seeing, right? Every company is using data lake. Every company is using data lake. Yes, that is the reality. It can be your AWS S3, it can be your Azure Data Lake Storage Gen 2, it can be your GCP GCS, it can be anything, but data lakes are there, right? And we are slowly just trying to eliminate SQL databases as much as we can. SQL databases are only being used with your, let's say, transactional data, and they are also being removed and eliminated by your Cosmos DB or any other famous, let's say DynamoDB. So these are like your semi-structured based databases. So these are being eliminated as well. But we cannot say like SQL databases are totally eliminated. No. DBAs and transactional data administrators are like still dealing with that data, but data engineers are totally working without SQL databases or almost working without SQL databases. They just use SQL databases as a source, but not as a destination. Got it? Very good. So data lake actually solved the problem of semi-structured and unstructured data, and obviously the cost as well. So everything was going smooth. What happened after that? Let me just tell you. So the thing is, okay, data is cheap, storage is cheap, we can just store every data, and we do not need to actually worry about anything. Okay, so tell me just one thing. You as a data engineer, why you are doing all those stuff? Just to serve someone, right? You need to serve someone. So you serve data analysts, you serve two data scientists. So when you serve your data, that data is being used to create dashboards, to create reports. So when data lake was serving data to data scientists, everything was perfect. Everything was perfect. There were no like major problems. There were like some minor problem, but not major problems. But when report builders, or let's say Power BI people, or let's say BI report builders, data analysts were actually using that data, they were not performant enough to build their reports. Why? Because when we build reports on top of your structured data, we get amazing features such as, let me just list some of them. So we get features something called as, let's say, your asset properties, or let's say asset transactions. Okay, we get something called as indexing. We get something called as data versioning, which is also very famous with Grant and like rollback in your SQL databases. So let's say rollback, revoke and rollback, these kinds of things. If you just want to provide some access to particular data, it is also called a data masking. So all those things were missing. Why? Why? Because these are only available when you just form the data in the structured format, because they have a schema, they have some information. They can just apply those changes on the schema level, not on the data level. So let's say you want to just perform masking, data masking. You want to just mask one data masking is nothing but just hiding some columns, or some, you can say, information stored in that particular column. You just see xxx, like you're just trying to hide the information, like let's say double x, double y, double z, something like this. So all these things actually get applied on the schema level, then it gets inherited. But in the form of, like in the case of semi-structured unstructured data, which is stored in the data lake, there is actually not any kind of metadata layer. There are just files. There are just files. That's it. And whenever you just build reports on top of files, they are not performant. It takes a lot of time to actually throw you the data, because you cannot optimize it, right? You cannot optimize it. And it's not just about indexing. It's not just about like we do not have asset properties. There are like some major problems as well. Let's say if you want to just time travel, which is also called a data versioning, how will you do that? How will you do that? Because these are just files. So all those problems started making a really big difference, that they were not able to actually work with data lake. Then we got something called as open table format. Open table format. So instead of table format, we are working with open table format. What is the difference? So obviously it behaves same as table format, but it is actually not a table format. It is much more than that. And let me just tell you why. So let's say what we did, we use the same data lakes. Yes, we use the same data lakes. We used your same, let's say if you are using cloud, we are using still like S3 buckets. We are still using Azure Data Lake Storage Gen 2. We are still using your GCP GCS still. But what we did, we just created a kind of metadata layer, which is also called as structured layer on top of your data lake. Yes, we just applied this structured layer on top of your data lake. And what actually happened after that? When we just applied this structured layer on top of your data lake, we were able to do all those things that we do with data warehouse with this thing. How? Because this metadata layer stores all the information for your schema, stores all the information about your time traveling, data versioning, and all the information for like indexing. There are some crazy optimization techniques as well that we will be just talking about in much detail right now in this video. So there were like so many crazy things which actually were not available in structured data, which are now available in like open table format. Can you imagine? So you get everything that you get in structured database, like your normal data warehouse, plus optimization techniques. Why? Because when you just work with big data, you need to compress the data. Okay, you need to just apply some storage cost optimization techniques as well, so that you can just save more money. Data lakes are already cheap, but to save more money. Okay, and on top of it, it also allows streaming. You can also stream the data. That is the craziest thing. Don't worry, I will just tell you about streaming as well in this video. Just be with me. So open table formats actually solve the problem of table format. See, here we had table format, but in data lake we didn't have any kind of table format. Here we introduced open table format. Got it? So open table format, that's why it is a big thing right now. That is why it is the most important thing in the world of data engineering. Why? I have talked about so much about open table formats, but I decided to just create a dedicated video on it, because I always prioritize my data fam, my lovely data fam, to just know a lot of about open table formats, because this is the future. I'm not saying like no one else is talking about open table formats. I don't want to comment on anyone, but I want my data fam to just know everything, to just know the latest trends. I know data engineering with those SQL databases, those PostgreSQL databases are important, but this is much more important right now. You cannot neglect this. You cannot neglect this. Got it? So that is why I have created this dedicated video, and you will learn all the things in the world of open table formats today. I promise you. Trust me. You will learn all the things. And let's talk about some of the popular open table formats that we have currently in the market. And we have three most popular open table formats right now. The one is this Apache Iceberg, and this is very much popular if you are working with AWS people just prioritize using Apache Iceberg a lot. Okay, then we have something called as Delta Lake. This is my personal favorite. Why? Because Data Lake is like, you can say, backbone of Databricks right now, and Databricks just provides amazing integration with this feature Delta Lake, because they have created this, so they are the owner. So I like Azure people, Databricks people, and I think now everyone is like loving Delta Lake. There's a reason behind it. Delta Lake is the most important and the most successful open table format framework right now among all the three. Okay, then the third one we have Apache Hudi. Hudio, Apache Hudi. So third one is Apache Hudi. So as I just mentioned that Delta Lake, by the way, these are similar to, let's say, your three cloud platforms. Like if you master one, you can easily grasp the other one, because the fundamentals are same. Fundamental and working and the framework will be the same. The only thing that will differ in all these three is just their optimization techniques. Trust me, trust me. They're gonna still have the same metadata layer. They're gonna still have that particular transactional log, which will save all the transaction details in the form of JSON files. They will still have all those things, but only thing that will change is optimization. That's it. So that is why just master one, you will learn the other two as well. And as I just mentioned that this is the most popular one and the most successful open table format framework right now, and you can just check it on Google and any on other, like let's say blog as well. So Delta Lake is the most popular one that every company is looking for right now. So we wanna master Delta Lake today. We wanna master Delta Lake open table format today. And trust me, I will just tell you each and everything from scratch. So if you do not have any kind of experience, any kind of knowledge, and let me just talk about prerequisites for this video, nothing, nothing, nothing. Just excitement to learn open table format. That's it. Because this is a new thing, bro. This is a new thing. You do not need to worry at all. I will just tell you everything. So it's high time to actually get started with this. And to just cover Delta Lake, we will just create an open, or let's say community account of Databricks, so that we can actually work with on Delta Lake efficiently, and we do not need to worry about any management, any cluster, anything. And Databricks is the best platform to practice Delta Lake, and it's free, and it is very easy to create a community account. So I will just tell you how to just go with that process as well. So do not need to worry. Now just take out your notebook and just hit the subscribe button if you haven't subscribed right now, and just share this video with your friends so that they can also learn. Share this video with your team members as well so that they can learn and help in your organization. So in order to create your free Databricks Community Edition account, just go on Google and just type Databricks Community Edition. Yeah, search it, and then do not go to login page because it will just directly ask you for the credentials, and just scroll down and just try for, oh, there are two links. So basically you can either click on this one, Databricks Community, and Databricks try it for free. Just click on this one. Okay, just click on this one and it will actually take you to this page. So what I will recommend you, just scroll down, okay, they have not provided here. So I think I can also click here as well, or what I will do, I will simply click on try Databricks for free. So you can also click on this link. Yeah, they just keep on changing their web page, I don't know why. So just click on try Databricks. Okay, then here they have, like, by the way, they have just started a great initiative where you can actually create your real Databricks workspace with having all the features. But yeah, you cannot create, like, actually upload some content, and you cannot actually see that data. And in order to understand open table formats, you actually need to see the data. So we'll not go with use express setup. Okay, so you need to simply focus on this one. Looking for Database Community Edition, click here. You need to just click on this one. Okay, now they are saying, like, sign up for community edition. So you can simply put your email ID if you do not have any community edition before, and if you have, then you can obviously use the existing one. So I already have, so I will be using my already created account. You can just click on this box and just put your email. You can actually create your community edition account. Okay, so this is the home page that you will be seeing when you will be just putting your email ID. Okay, so there's nothing much to explain in Databricks because we are just focusing more on the open table format today. And still, I would just like to give you a quick overview. So this is the Databricks workspace, okay, which is a very popular tool in order to work with data engineering. Okay, so this is a kind of tab that you see workspace. Basically, this is a kind of folder that we create in which we just put all the things. Let's say you want to put your notebooks, you will just put it there. If you just want to create folders within workspace, you can just do that. And obviously, as the name suggests, recents, this is basically used for when you just, let's say, open notebook number 2, so it will just show it there. That's it, like your recent history. Then search, just ignore it. Then catalog. Basically, this is an important area because this is the area where we'll be actually uploading the data and where we'll be actually working with the catalogs and data. And this is the area that is missing in the traditional, you can say, Databricks workspace, that it provides using Express setup, because actually it does not hold anything, right? But in order to just work with open table formats, you need to just see the data with your eyes. So that is why I just decided this one. Then workflows, this is very important when you just need to, let's say, work with orchestration. If you just want to orchestrate the data similar to ADF, that is Azure Data Factory, you can just do this in Databricks as well. Okay, then compute. Obviously, compute is the cluster that we use to process our data, and in the community edition we do not actually need to worry about compute because everything is free and it just runs one, I think, default compute with 2 cores. That's it, just basic compute and enough to work with our data. That's it, bro. And then finally, machine learning to just work with ML ops and ML things. Okay, so let me show you. Click on workflows, and obviously it is not available for this particular one because this is a community edition. We need to just upgrade to Databricks subscription, which we are not doing. Okay, don't worry. Okay. So first of all, we will just simply go to workspace and just click on this workspace. So here you will see all the folders that are created within workspace. So I can simply create a new workspace. Simply click on create and then click on folder, and then I will simply say open table format. Okay, then click on create. So this is your folder, and this folder will be using throughout this course, throughout this video. And in this particular folder we'll be creating lots of notebooks. Okay, so let's quickly create one notebook. And obviously, oh nice, it's done. By the way, if you do not like this black color, I can just remove it. Okay, and because I also like white color when I just work with Databricks. Okay, so I will just remove it. So before that, let me just give you a quick overview of notebooks. If you are new to notebooks, nothing special. If you have worked with, let's say, Jupyter notebooks or any other kind of notebook, everything is same, bro. Notebooks are same. So first of all, let me just rename my notebook, and I will simply say notebook 1. Okay, and in order to work with your notebook, you first need to connect your notebook to a cluster. Simply click on connect, and it will say, hey, this is the cluster, this is the configuration, and runtime will be 12.2 enough, and Spark version 3.3.2, and yeah, obviously we will get 2 cores. And if you just click on advanced configuration, you will see all the configuration like 15 GB memory free, so you can actually upload 15 GB of data, but do not upload. Okay, then click on create compute, or click on cancel and click on create compute from here as well, or the traditional way. So see, now I'll be going to the recent tab to just show you. See, notebook 1, I can simply click on it, and you can even create compute from here as well. Simply click on create, attach and run. That's it. So now you can see it is starting. So it is our start, it is starting our cluster. Meanwhile, let me just show you some other things as well. So in order to just, let's say, work with Databricks, obviously you need some data, right? So I have prepared some CSV files that you can also use, and from where you can download those files, you can just easily download that file from my GitHub. Let me just show you right now, and we will be just using this catalog tab to upload our data. Okay, so let me show you my GitHub repository. So this is my repository for this particular video, and you can just check this open table format repository. I will just provide the link in the description, and these are the CSV files that we'll be using throughout this video. Okay, so you can just download the CSV files and you can just get started with this video. Okay, so let's actually get started with the open table format implementation. So now you'll be saying, hey Ansh, you haven't even told us how Delta Lake, like how does it look like when we just work with Delta format, Delta Lake, nothing. I know, because I have structured this video in that way, and I will just tell you all the things at the right moment. So hold your emotions and just trust me, and by the end of this video you wanna just drop some lovely comments on this video. Trust me, trust me, trust me, trust me. Okay, so let's get started. So I have just turned on the lights of my Databricks notebook, and now it looks good. I personally like white version of Databricks. I don't know why. So as you can see, my cluster is also ready. It shows that it is online. No, it shows that it is ready. Okay, so first of all, what we'll be doing, we will upload the data to our catalog. So how we can just do that? Simply go to your catalog tab. Okay, just click on it. Then you will see something called as these tables. So it will take some time, and these are all the database tables and everything. And you can also click on DBFS, and you will see all the folders that are here. Okay, so what you can do, you can simply upload data directly here, or you can simply go inside user, or let's say file store, and just click on it, and then you will see so many folders. So I have already created some folders here, and if you just want to just create a new folder, you can also create that one, not a big deal. So for this particular video, what you will be doing, let's create a new folder. So simply go to DBFS, and here you can simply, let me just remove it. Oh, no cluster is attached. Nice. So let's try to upload in local disk, or let's say try to upload in user. Yeah, let's try to upload in user. This looks this looks good. Okay, and yeah, perfect. So now first of all, in order to just upload the data, obviously you should have downloaded those CSV files in your machine, and in order to upload the data, simply click on this upload button. Or if you want to create, let's say, a folder within this, let's say you want to just create a new folder, and obviously we should create a new folder, right? So what you can do, simply click on upload button, and then you get the opportunity to add a call like table name, or let's say table name is equivalent to like folder name. So you can just actually add the folder name. Let's say within file store, I want to add a kind of folder that will act as a container, let's say root folder for my this video. So what I can just do, I can just provide, let's say, open table. So this is my root folder. Okay, and within this I will create one folder called as source, or let's say raw data, because this is my parent folder, open table, or let me just add format as well, it makes more sense. Then within this I will create another folder, it's called raw data. Okay, raw data is equivalent to source. Okay, so it makes sense. So now I can simply click on drop files to upload. So when I just click on it, I can actually grab the files which are there in my system that you have already downloaded from GitHub. Okay, so I have selected all the 3 files. Okay, and let me just click on done, and now you will see that it has created, see, I can just use this scroller, and you can see that within my user I have, hey, where's the table? Oh, they have just uploaded the data in the file store maybe. Yeah, no worries. So just go to the file store, and within this I have a folder called open table format. So just click on it, and then, because I just selected file store instead of user, not a big deal. So if you just want to store the data in file store, just go with it, and this way you can just use my notebook as well that I will be uploading in my GitHub as well. So just store your data in file store, not a big deal, because I did not want to save my data here because I already have so many folders, but that's it, no worries. So let me just click on this open table format, and within this folder I will see that I have my main folder, which is raw data. Within this I have these 3 files sorted. So what I will do now, I will use these 3 files, and obviously for the beginning I will just read one file only, let's say sales data first, and I will use PySpark coding, PySpark reader API to read this data, and I will convert this data into the open table format, which is your delta format, because in today's video we are using and learning delta. Okay, so we are just trying to convert this CSV into your open table format, which is delta format, and we will just save this data in our repository here, which is your DBFS. And I will show you then how does it look like when we convert a CSV into a delta format. How does your open table format look like? Okay, got it? So let me just do that. So in order to just read your data, so we will simply use, let's say, first of all, let me just add a markdown, because you will be using this notebook, so I want you to just feel good. Okay, let me just add data reading CSV. Let me just run it, and if you do not know how to run the cell, you can simply click shift plus enter and it will just run the cell. Okay, or you can also click on this run button, it will also run the cell. It's all up to you. So now let's read the data, and in order to read the data we will simply use our code, which is df equals spark dot read dot format, and format is in the form of CSV. Then we need to just say dot option, and we need to say header equals true, because in CSV do not have any kind of schema. CSV are just your text files. And then option, we need to simply say infer schema true. What infer schema will do, it will simply guess the schema and will just apply the schema on top of it, like this column is of int type, this column is of string type, automatically. Okay, then we are good to just load the data, and now I want to just get the location. And how I can just get the location, simply click on catalog, simply click on DBFS, click on file store and this, and right click on it, you will get the copy path. Simply copy the path, and obviously if you are just using Spark API format, you can either click on copy, or you can also use the relative URL. I can simply go with the relative URL. Click on close and click on close, and then just put this URL here, and you are good to go. And I also want to see the data, so I will simply say display df. Simply run the cell, and it will just show you the data frame it has created on top of your CSV format. And this is like normal thing that we usually do, right? Oh, what happened, man? Path does not exist. Really? Why? Why? Oh, I just copied DBFS as well. Why did I write DBFS? Why? Just remove DBFS. We do not need to write DBFS. So Now it will just show you the data which is in the CSV format. See, we have branch ID, dealer ID, model ID, revenue, blah, blah, blah. So many columns, right? And we have like 95 rows in this particular column, in this particular data as well. So this is fine. There's nothing new in it. There's nothing new in it, right? Let me show you what will be the new. So now we are just using this data frame. Okay. Now we will be just converting this data frame into the delta format, which is one of the most popular open table format. Okay. Let me just convert this, and how we can just use this, like convert this same data frame writer API, which is df.write dot format. And here is the game which is like changing. You just need to put delta. That's it. Just need to put delta, and after that simply write dot option. If you are obviously just storing this data somewhere else, you need to just specify the path. Okay, so I'll simply say path, and path will be this one. I will simply copy it, and there will be a small change, so do not copy as it is. Okay, just see what are the changes I'm making. So I do not want to store it in the raw data. I want to store it in the sync data. What is sync? It is a very popular term in Azure. We just use sync for destination. Okay, and obviously here I do not need to put the file name. Why? Because whenever, just remember this thing, whenever we are just converting a traditional file into delta, we always just provide the path till folder level only. Till folder level, we can only create folders, not files. Okay, so we'll simply say sales data. So I will simply create the folder within this. That's it. That's it. And you will see the magic after this. Really? I think so. Yeah. Then I just need to say dot save. Oh, dot save. E. Okay. Perfect. So now it will actually convert my CSV file, and now it's time to just give you a kind of brief introduction of delta format, because something magical will happen right now and you will get to know what. Okay. So it is just running Spark jobs. So far six Spark jobs are run. Okay, so let me just show you what happened. Okay, first of all, what are you expecting? I know what are you expecting. You will say, hey, this is our source. Okay, this is our source, and this is our destination, and here we have CSV file .csv, and here we will be having, obviously because open table format works with files. Okay, so you would say we will be having data with form of dot delta. This can be your expectation. Okay, let me show you what will happen. Okay, let me just take you to the catalog. Okay, just go to dbfs, and this is the thing where actually knowledge will be tested, because it's very easy to work with delta without actually knowing the backend scenes, when you just need to write the code tak. But when you actually sit in the interviews, you need to know everything. What is happening behind the scenes, bro? What is happening behind the scenes? Okay, so what will happen? I will simply click on sync data. Within this I have sales data. Okay, within this you are expecting dot delta format file, right? Let me just click on it. What? This is something else. We have delta log, a kind of folder which we were not expecting. And what is this? This is, let me just hover over this. So now I think you can just see. Yeah, so now you can see it is saying dot parquet. What? We saved our data in the delta format. We didn't save our data in parquet format. And what is this delta log, man? What is this? We didn't even create it. So now it's time to actually give you the reality check of open table format and how does it work behind the scenes. So this is your folder that you created, right? Okay, so basically this is your data. Sorted. And I just told you, instead of saving the files, we just save the folder. Okay, so this is your data frame that you written in the form of, that you wrote in the form of delta. Okay, let me just tell you what happens when you just convert your data in the delta format. So let's try to understand delta format in detail and behind the scenes, that what actually happens. So let's say you have your CSV file, okay, or let's say any file, bro, any file. Okay, so you are just trying to convert this file, or let's say this is your source. Okay, let me just write here, this is just your source. Okay, and you are just trying to read this data frame and trying to write this data to a destination. Makes sense? Like you just created the data frame, on top of it applied some transformation and just wrote this data. Sorted. Okay, so then you just wrote this data, and this data should be written in the form of delta. Make sense? But what actually happened and what actually happens, this data will not be in the dot delta format. And let me just give you a reality check. We do not have any kind of thing that's called dot delta. We do not have this thing. Wow, yes, we do not have anything. So what it does, this file will be stored in the form of Parquet. Wow, okay, this file will be stored in the form of Parquet automatically. Okay, so whenever you want to convert our data into open table format and obviously delta, it will be created on top of Parquet. So it will convert your file in the Parquet format. Okay, so there's nothing special, right? It just converted into Parquet format. And how it enables your ACID properties, blah blah, all those things that you talked about, bro, because this is just a Parquet format, and Parquet format is also like normal file that we store in data lake. I know you are right, but what it does along with that, it will create this folder which is called transactional log. This is the game changer. This is the backbone of your open table format. So what it does, first of all, this is called as delta log. Okay, and this is called as, let's say, your transactional log. So what it does, this is a transaction log. What it does, it will just store all the transactions. What are the transactions and what can be the transaction? Transactions can be, let's say, you added this file. Okay, this will be converted into Parquet format. It will be having some dirty name, part 000 blah 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 blah. Okay, and this information will be stored in this delta log. Yes, I will just show you, don't worry. This information will be stored in the delta log, and it will be written, hey, that this is the schema. Okay, this is the schema. Schema means like your all the columns, all the data types. This is the name of the file, that what it needs to do. It will be storing all the information, everything. Okay, it will be storing that information and everything. Okay, makes sense. And let's say you added another file. Let's say there's another file. You added this file. So now there'll be another Parquet file. This information will be also stored in this delta log, this one, this delta log. So this is keeping a track of all those things. And how? Because this delta log is storing something called as your JSON files. These JSON files are actually holding all those information, and every new transaction creates a new JSON file. So initially you will be seeing JSON file called as 0000000.json, and then next transaction will be 0000001.json. So every JSON file is holding a transaction, the transaction. So let's say you added one file, it will be stored in this JSON file. Then you added one more file. Okay, it will say, hey, add this file as well in this particular JSON. It will not repeat the information. And first of all, let me just make it clear. Every JSON file is not storing the state of a table. No, that information is false. Whenever it needs to just give you the right state, or let's say the current state, the most latest state, it needs to go through all the JSON files, because this file, okay, is stored in this JSON. This information, like information for this file, is stored in this JSON file. That doesn't mean like, okay, it will just read the latest state, it will just read the latest state of the table, so it just needs to read this JSON file. No, that's not how it works. it will read all the JSON files. So now a quick question. You will say, hey Anshlamba, there can be like so many transactions, and within a month or let's say within a year, there'll be like thousands of JSON files. Yes, you are right. So will it read all the thousands files? No. You just said that it reads all the files. Yeah, I said it. So now what it creates, what it does, it will create a kind of transaction history as well. So whenever it will reach the number 10 JSON file, every 10th file, or let's say every 11th file, because it starts from 0, so every 11th file will store all the information of the past 10 files. So let's say there is the 12th file coming, or let's say 11th JSON, because it starts from 0. So if we have, let's say 11th file, or let's say 12th file coming, okay, so it will just read 10 JSON. Why? Because 10th JSON has all the information of the previous versions, and it will just read the 11 JSON. That's it. So that's how it keeps all the history. And same will happen with the 20th JSON as well. So 20th JSON will hold all the information of past versions, everything. That's how it maintains time travel, transactions, everything. And you will learn everything, you will see everything. This is just the conceptual understanding for you. Okay, so let me just show you that delta log, how does it look when you just store it in your Databricks default storage. Okay, let me show you the JSON files that I'm talking about here. Okay, so let me just show you how you can actually view the content inside JSON, because DBFS does not allow you to see like or preview the data inside JSON. Okay, so what you can do, simply go to your catalog and simply go to your DBFS, and within this you just need to go to your sync data, within this sales data, within this delta log, within this your JSON. So simply copy the path of this, okay, and we will simply run our utility command. So we have fs utility, and we will simply say head, and do not forget to remove this dbfs part. Okay, simply run it. So as you can see, like all the things are written here, everything. So obviously metadata ID, and you can see field names. So all the field names are here, like name, branch ID, type, string. So all your metadata is saved here in this particular file. And it also says like just add this particular file, which is called this add. So it gives the add instructions to your delta open table format, that this file with this particular name needs to be added in our table, in our open table format. So let's say if I remove some data, or you will just get to know all those things. If you just remove some partitions, everything will be written here inside this delta log that okay, just remove this partition. So now it's time to actually see the DML commands that you can run, and how you can just create the table as well, like the real table using delta. Okay, so let me just tell you how you can just do that, and then you will actually see everything, how it behaves when you just apply any kind of manipulation command. Okay, so now what we'll be doing, we will simply create a delta table, and let me just remove this cell, this one, let's delete it. So let's create a table. And by the way, if you just want to see the content, you can also create a JSON data frame. Let me just show you. Df equals spark.read.json, and then you can just provide that particular path. Do not forget to remove the dbfs, and then just say display df, and it will just show you all the things. So basically we have like just two different kinds of fields. One is add and one is commit info. So it simply says like add this, and what it needs to add, it needs to add this particular file name, this path. See, that's it. And you will see a lot of stuff now, because we will be just working with so many JSON things. Okay, so for now, what we'll be doing, we will simply create our table, delta table. And how we can just create delta table, it is very simple, similar to your DDL command. So simply say create table, and table name will be, let's say, my delta table. Okay, then simple DDL schema. Let's say I want to create a column called ID, which is of int type, name, which is of string type, then salary again, which is of, let's say, double type. Okay, then I will simply say using delta, then it will be my delta table, which is of open table format. Okay, Then I also need to define the location where I need to store this table. So I will simply grab the location from here and let's create the table at this location. Simply carefully see the location. So I will simply create the table in the folder called first delta table. Make sense? Okay, let's run this. So what it will do, it will simply create the delta table at this particular path and you will actually see table created. Okay, let me show you. Go to catalog and go to, okay, so as you can see, it has registered our table as well under default schema because we did not create any schema. We do not need to create any schema. We can just work with any you can say schema, and if you just want to create schema first, you can create. Okay, not a big deal. So go to dbfs and go to file store and then just go to your in sync data. Yeah, within sync data you have this folder called my first table or first delta table. Okay, simply click on this. By the way, let's create a schema as well because then you can easily query as well. So let's keep it as it is and let's create a new table under schema. So I will simply first create the schema, create schema, and schema name will be, let's say, bronze. Okay, let's run this. Okay, now let's recreate this table under this schema, and table name is my delta table, and this will be my folder name as well. It will be easier to find it, and in the real world as well, we just keep the table name and folder name same so that you can easily track it. Now let me just create it. Oops. Oh, I need to just define the schema. So schema is bronze. Yeah, perfect. So now our table will be created, and now you can also see the catalog from here as well. Simply click on catalog and you will see all the catalogs. This is our bronze schema. Within this we have delta table. Okay, so now it's time to add some data. So first DML command that you can use is insert. Okay, let's try to insert some data within this and let's see how it behaves. So I will simply say insert into, table name is bronze dot my delta table, and what data I need to insert, I will simply say 1 and then name will be AA and then salary will be, let's say, 100. Okay, then let's say 2, then name will be BB and then salary, let's say 200. Let's insert this data. Let's run this command. This is our first insert command, and what it is saying, bro, incompatible types. Oh, I just put 200 in single quotes. So by the way, this is very good feature, and let me just talk about this as well. This is called schema enforcement within your delta table format, or let's say open table format using delta. So you have just seen, by the way, it's good that we saw this error. So we have just created this table. Okay, we have created this table and we have dedicatedly told it that we need to just store this data of only this data types. This is called schema enforcement in delta lake, or let's say delta format or open table format using delta architecture. This is called schema enforcement. So whenever your file, your Parquet file, if having, let's say, data of any of different data type, any column of different data type, it will not accept it. This is called schema enforcement. It will not accept it. This is a really cool feature, and this is a feature that guarantees that schema will not break. This is the most important feature which is only available in your SQL databases, and with the help of open table format, this is also available here. Schema enforcement. But Ansh, you just said that we can also evolve the schema. Yes, we will discuss that in the schema evolution chapter. Schema evolution. We can also evolve the schema. No need to worry. Okay. But first we need to understand this, that schema evolution, schema enforcement is there. And we have a dedicated chapter on schema enforcement and schema evolution. So do not need to worry. But this error came. So I just thought like I should just give you a hint here as well. Okay. Very good. So now we have inserted some data. You want to see what will happen. Okay, let me just insert this data multiple times. Okay, let me just run this command for one more time. Okay, perfect. So now our table is created, and if you want to query this data, you can simply run select asterisk from bronze dot my delta table. Let me just run it. So it will simply run your table, and you will say, hey, it looks exactly same as our structured data. Yes, that is the power of open table format. It has just applied a structure on top of your file, and now you know what is the actual data format. Packet, just a file, and now how you're just displaying it in the form of structure. And do you know the power of delta format? Even if you do not create table, you can still display the data in the form of table. How? Let me just show you. Let me just take you to our previous example in which we just created this table and we just stored the data in this particular folder, and we do not have any kind of table on top of it, and we didn't create it, right? You still can query it using this function. Let me just show you. It's called select asterisk from, where you just need to define delta dot, and you just need to enter ticks. These are not single quotes, these are ticks, which is just available after tab button. Okay, just towards left of your one. So this is ticks. Then you just need to define this location. That's it. It will automatically gives you the same result that you see in the table. Just wait. See, did we create any table? No. No. Still, you can just use this with the help of open table format. Okay, it just creates a metadata layer on top of your file. See, even without tables, you can just access it like table. Cool features, cool. So now let's get back to the topic. So now if I just go to the catalogs, okay, and if I just go to the dbfs, then I will simply go to my delta table. Within this time I have two files. Why? Because we wrote the data two times, so there are two packet files. So how many JSON files will we be having in delta log? The answer is 2. Let me just click on it and see. Here we have total 3, by the way. Okay, let me just tell you like why 3. So basically 0, and then we have 1. Okay, then we have 2. Okay, why 0, 1, 2? Why not just 2? So just to remember the thing that we have done, first we created the table. So that information will be stored as well. Oh, yeah, makes sense. Okay. So this 0 JSON stores the table definition, like this table was created. Then it says, hey, this data was added. Then, hey, this data was again added. And now if you want to just see how it look like, how does it look when you just query these files? Let me just show you. Let me just show you. Let me just copy this one, JSON, and let me just copy the path. Okay, and I will just validate my point that this particular JSON file will only store the information for this particular file, not both the files. Let me just show you. Okay, so how you can just do that? We have a DF framework ready. Where was that? We can just leverage that one. Yeah, this one. So here I can just paste this particular location after removing dbfs. Okay, let me just run it and let's see what we get. Perfect. So now as you can see, let me just expand it, click on this, and then we can see that stats and name. See, now it has also shown you the stats, like this is the minimum date, this is the maximum date, so it also stores the stats. Why? To just optimize the table, and we will just talk about it in the optimization chapter, so do not need to worry at all. So this is the information that it has saved, and it simply said this is the path. This is the path. That's it. This is the packet file that you need to add. And how? See, this is the column add. Only one file, not two. Only one. Only one. Got it? And where is the previous file? In the previous JSON file. So every time it will just read all the JSON. And now I will show you something else. I will just run this command. This one. 10 times more, and you will see it will create a checkpoint for previous versions instead of reading all the JSON all the JSON files, the thing that we just discussed. Okay, let me just run it 10 times. Okay, now it is running for like one time, Okay, second, third, fourth, and then fifth, sixth, seventh, eighth, 9, and last 10. Almost there. Yeah, 10. So perfect. So now we have just inserted our data. Basically, we have made 10 plus transactions. So what will happen? It will first create all the JSON files till 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 JSON files are done. But on the 11th JSON file, which is the 10th one, like because it is starting from 0. So the 10th JSON file will be created, and then it will also create the checkpoint for all the previous 11 files. So 11th file will be treated as the checkpoint for all the previous 10 plus the current plus like 11th. Let me just show you. Go to catalog, go to DBFS, go to file store, go to open table format, sync data, my delta table. See, these are all the files. Now go to delta log. So these are all the files created. See, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 10th is checkpoint. See, 10th is checkpoint, and then 11th, and then 12th. So now if I just insert 13th.json, and in order to return the latest state of the table, it will read 10th.checkpoint, and then 11th, then 12th. So in short, it reads all the JSON files, but it will just leverages the checkpoint. It doesn't mean that it just needs to read 12.json and yeah, you are good to see the latest file, latest state of table. No, no, no. Oh man. So this was all about the insertion, and now it's actually time to see some DML commands, like real DML commands, when we just need to like update the data, delete the data. What will happen in that particular scenario? So in order to understand that, we will just create a new table from scratch, and you will just leverage everything like data versioning, time travel, everything. And for that, we first need to turn off one thing. No, it's not the lights. We need to turn off something called as deletion vectors, because deletion vectors is the recent addition in the world of Delta Lake that we need to first turn off. Only then you can just understand. And once you understand all the concepts, then I will introduce the deletion vector. Because if I will just show you everything from the deletion vector point of view, you will not understand anything. No, that's why I have to create this dedicated video in order to just explain all the things. Okay, so now, so what I will do, I will simply create a new table. Okay, let's create a new table, and let me just leverage the same definition, table definition. And I hope now you're learning a lot in the world of open table formats, and now you're slowly looking at the power that it has, right? So simply paste this table, and this will be my my delta table 2, let's say. Okay, then add to here as well, then just create it. Okay, so now you know the result. Let me just ask you a quick question. So what will happen in the delta log? Obviously, it will just create one JSON file which will hold the definition of this table. Make sense? Very good, very good, very good, very good. So now let's turn off the deletion vectors. And how we can just turn off the deletion vectors? Let me just grab the code for it. Actually, the code available code is available just to turn it on, but now we can just use that code to turn it off as well. Not a big deal. Okay, so I'll simply say deletion vector delta lake. Let me just grab it for you. Okay, this is the official documentation, by the way. So yeah, this is the code. Let me just copy it, and let me just paste it here. So I will simply alter alter my table, and the table is bronze dot my delta table 2. Set table properties. We'll go to the next line. Why? Just kidding, bro. You can just put the same thing in the one line. Okay, and instead of true, I will simply make it false. Haha. Einstein by smart. Just run it, and it will just turn off the deletion vector. That's it. Okay, and this information will also be stored in the your JSON file. Everything will be stored there, bro. Everything. So now let's be serious. Okay, so now what we will be doing, we will first insert some data. Okay, let me just grab the insert code, because now you need to understand everything. So let me just copy this code. Okay, let me just insert this data. Let me just run this. Perfect. Code is added. Okay, code is added. Very good. So what it will do, it will just insert the data. Very good. Now let me just insert one more set of data. Okay, and let me just change the keys this time. I will make it 3. I'll make it 4. Name will be, let's say, XX. YY. Salaries are same. Just insert this data. So what will happen? What will happen? Obviously there will be like 2 Parquet files. Okay, and total 4 JSON logs. Okay, let me just confirm. Catalog, DBFS, file store, and we just need to go to my delta table 2. Okay, 2 Parquet files where, oh man, we just inserted data into delta table. So let's insert it to 2. Okay, just insert it. Okay, perfect. Let me just run this as well. Just run it. Okay, just insert the data in the table 2, not table 1. Okay, so now let's confirm quickly. So now see 2 Parquet files and how many delta logs? 4. Perfect. 0, 1, 2, 3. Done. 4 JSON logs. 1 for creation, 1 for removal of deletion vector. Third is for table data addition. Fourth is for table data addition. Got it? 4 JSON files. Very good. So now what I'll be doing? So what I will just do, I will just make some changes in this table. Yes, I will just apply some update command. So let me just quickly apply some update command. Let's say I want to update table. Let me just change the language to SQL. So update table, and what is my table name? This is my table name. Okay, update table. Oops, I just ran it. Instead of hitting enter, I just hit shift enter. So I will simply say set. So what I'm going to do, I will simply change the value of this particular row, which is row number 4. So instead of YY, I will just convert it into ZZ or ZZ. Okay, so currently we have just 2 Parquet files. Remember this, because now it will just test your knowledge and it will just add one more thing in your knowledge base. Okay, so let me just do that. Update set and name equals to ZZ, where ID equals to 4. Make sense? Makes sense. Let me just run this. Okay, so now what will happen to our Parquet files? What will happen? And what will happen in the delta log? You will simply say it will just update the file, right? Okay, let me just show you the delta log. What will happen? And let me just go to catalog and let me just go to my DBFS and let me just go to my table 2. Okay, very good. We have JSON 4. This is expected. Let me just see file. Hey, Ansh Lamba. Yeah. Why do we have third file? We didn't include any data. We didn't insert any data. Why do we have this? So it's time to talk about the DML commands and open table format. So let me just tell you how it performs behind the scenes. Okay. So first of all, I will also talk about JSON as well, like what will be there in the JSON and why it is there. So let me firstly quickly query this JSON file. Let me copy the path. Okay. By the way, we have the path in the above code, if I'm not wrong, the DF code. I just need to change the number. So yeah, this one. So here I can simply change the table name to 2 and then 4. And then I will just show you what will happen. So perfect. So what happened? It simply said that add this particular path. Why? Why did it ask it to add this particular Parquet file? And what is there in this Parquet file? Because we have not written any data, any new data. Why? Okay, let me just tell you. Wait. Let me just show you something else as well. We have another column. It's called remove. Whoa. Wait. What is there? Okay, let me show you. So it said that remove this partition. Ansh Lamba. See, today is Sunday. We know that. And tomorrow we're gonna just go to our office. So just explain us what just happened. Okay. Hold on. So basically, just note the partition number first of all, because these are important. So the partition number is 0AD. Okay, 0AD. This one, 0AD. Can you see now? Can you see now? Can you see now? Okay. 0AD. Okay, this is the partition that it removed. Okay, and this is the partition that it added. Why? And this partition name is 1B3. Let me just tell you. And no one will tell you this. Trust me. So, what will happen and what actually happened? So, basically, this is our catalog where we have all the files. Okay, where we have everything. These files. So, basically, this file is new, as we know, because it is just added. Okay, just forget about this file. Forget about this file. So currently, before updating this table, we just had these two files. Okay, it's very simple, bro. Do not make it complex. I know, like you are seeing very complex things everywhere. Let me just make it very clear. So these were the two files. Sorted. These were the two files there. Okay, let me just draw the rectangle again. Yeah, these were the two files, 0AD and 753. 0AD and 753. Sorted. So what happened? Your 0AD partition actually had the data for 3 and 4 ID. Okay, because this was the second partition, second bucket file. Your 753 partition had the data for ID 1, 2. Make sense? Sorted. So these are two different partitions. Okay, one partition, second partition. Very good. Now, whenever we just perform any kind of DML command, any DML in open table, okay, any DML, what it does, it will this is partition 1, okay, partition 1, partition 2. What it will do, it will take your packet file, it will simply make the changes in the new file. Yes, new file. So what it will do, so basically we know that our ID 3 and 4 is basically residing in this particular partition. Make sense? This is independent of this change, because this says, hey, I do not have ID 3 and 4, so do not touch me. Don't you dare touch me. So it will go to this partition 1, 0AD, in which it has ID 3 and 4. Okay, so what it will do, it will create a new partition. Okay, it will create a new partition, and what it will do, it will load the whole data of partition 1 to this new one with all the changes. So we made the changes in the ID 4, so it will make the change, but it will load into the new partition. Oh, so now this is our partition 1. Okay, makes sense. So now this partition is actually having the data for ID 3, 4. Makes sense. So here comes the concept of tombstoning. It's called. So what will happen behind the scenes in the log? So we know that Delta log stores all the information, right? So what it will do, it will simply say, hey bro, this partition is right. Do not need to do anything with this. So in the latest JSON, like 4 JSON, we do not have any information for this partition because this is untouched. Okay, it is untouched. Very good. So what it will do, it will simply say, hey, this partition is no more needed because this is changed. This is the updated partition. So remove this partition and add this partition. Remove this partition and add this partition in your latest state of the table. Got it? Got it? This is the same thing written in your JSON log as well. We have just seen. Okay, so let me just tell you the order. So let's say, let me just query the table and then you will see how it will run the JSON logs behind the scenes. So let's say you made the changes. Okay, you made the changes. Okay. So you then said, okay, I want to see the latest state of the table. So you will simply say select asterisk from your bronze dot my table 2. Run this. You will simply see, hey, I'm good. I can see ZZ instead of YY. And what will happen behind the scenes? Do you know? Do you know? It will simply go to the delta log. So basically it has like all the files, all the packet files, 0, 1, 2, 3, 4, all the files. Okay, all the files. We never delete the files in open table formats. We always soft delete the files. We can hard delete as well, but it will be discussed later on. Okay, so we always soft delete the files. That means we do not actually delete the file. We just tag it as deleted. That's it. Okay, so what will happen behind the scenes? You know that we have total JSON 0, 1, 2, 3, 4. Okay, so what it will do? We have, let's say, JSON 0. In 0, what we have? Table creation. Very good. What we have in 1? We disabled the deletion vectors. Okay, very good. Vector. Then in JSON in 2, what we have? Insert data ID equals to 1 or 2. Perfect. What we have in 3? Insert data for ID equals 3 or 4. Very good. Okay. Then I will just stop here. Okay. So what will happen? Here we have partitions as well, right? Let me just make it with blue. Partition 1, partition 2. Very good. So now let's talk about our let's talk about our next JSON 4. What will happen? We updated the data. Updated ID equals to 4. So it created the new partition. Okay, let me just tell you what are the things added in the JSON in brief. Table creation, deletion vector. Perfect. Here, what it says, let me use green or pink. I love pink color, bro. So it says add partition your 7.6 something which was untouched. Okay, 7.6 something. Okay, then it says on the third JSON add partition your 0.1 something that we just saw, like it was changed. Okay, 0 AD. Okay, 0 AD. Okay, but then here it says that add new partition which is called I don't remember the name, the new one that we just discussed. Okay, it was, I think, with the name, I don't remember the name. The new one, add new partition and remove this 0 AD. This information is stored in your JSON we have just seen. Okay, this is the flow that is running behind the scenes. Makes sense? Makes sense? So now let me just test your knowledge that you have learned so far. Let's say I want to delete from table bronze dot my, let me make it SQL, my data table 2 where ID equals to 3. Let's say I want to delete the ID. Let me delete it. What will happen? Tell me what will happen. Don't go back, just tell me what will happen. So now the correct answer is it will create another partition. Okay, it will create another partition, and this time which partition will be tombstoned? Tombstone means which will be soft deleted. Which one? The new one that it just created, because our ID number 3 is there. Let me just show you. Let me just go to the JSON 5. Okay, where is that? Yeah, JSON 5. So let me just run this. So see, here we have new partition called 2ED. Okay, and remove the new partition that it just created, which was 1B3. See, because this partition, this packet file was the latest packet file which was holding your 3 and 4 partition. Make sense? That's all about your DML commands and open table format. That's how it keeps track of everything. What is the advantage of keeping the files and not changing the existing files? If this question came into your mind right now, very good. You are really learning a lot and you are really thinking out of the box. So if this question came into your mind, very good, because you can simply say, hey, why it cannot change the existing partition? Why? let's say, let's say I made this statement and I actually did not want to run this statement. So I deleted this data by mistake. But now I want to bring back my data. How I can just do that? How? So here comes the role of data versioning and time travel, where you can actually go back and actually bring back the results. Data versioning and time travel. So if you just made the changes in the existing Parquet file, how will you just bring back the data again? That is another important feature that was only available in data warehouses, to just roll back the data, roll back the latest state of the data. Now we have this here as well. And how it just perform, let me just tell you. First of all, we need to understand this data versioning, then we can just understand time travel. Okay. So let me just tell you how it performs it. So basically, what it will do, we can actually see the versions of the data. Really? Yeah. We have a command called describe table, or let's say just table name. Oh man, just make it to SQL first. Describe and then bronze. Oh, describe bronze dot my table 2. Okay, that's it. Just run it. Describe table. Okay, I can simply say describe. Is it describe extended? I guess describe extended. Yeah. So this is your actually not describe. Wait. It's not describe. For data versioning, we use another command. It's called describe history. Yeah. We have so many describe commands. So we need to see history on this particular table. Perfect. That's what I wanted to see. So here, as you can see that this is the history of the whole table. Okay, this is the history of the whole table. So what it will do, it will simply, so by the way, here it is 0. Okay, so it says that first of all, it created the table. So if you just closely see, it says create table. So first of all, it created the table and the version was 0. Then we disabled the deletion vector using set table properties. It is there. Then we just written the data, then we just wrote the data, and then we updated the data, then we delete the data. So till here everything was fine, right? And we deleted the data in the version 5. So the latest version of the data is version 5. So in order to get back to the previous version, which version I need to use? Simple question. Obviously version 4. So we can actually time travel and we can actually restore our table based on that thing. Do you want to see? Let me just show you. So basically, in order to just run the time travel, so first of all, let me just show you how it works with select statement. If you just want to confirm, hey, this version is working fine, because obviously when you're learning, we have like very few versions, but in the real time you can have like so many versions. So what you need to do, simply say select asterisk, like normal select statement, select asterisk from bronze dot my table 2, and you just need to say version as of 4. Just run it. Just run it. Perfect. So now, can you see that deleted thing? Obviously not. You will say, hey, Anshlamba, it was not deleted. Oh, really? Let me just run this query then. Let me just run without version. See, it is not there in the latest version, right? But I can just travel back and I can see actually the record is there. So if you delete anything by mistake in production environment and your manager and seniors are shouting at you, just say, hey bro, take a chill pill and let me just bring back the data, because we have already watched open table format video by Ansh Lamba and now we know everything. Okay, so maybe your manager would have already watched my video. So basically, jokes apart. So basically, you can just go back to any version. Let's say you want to go back to the 3rd version when there was not even any update. So what it will do, it will simply show YY. See, instead of ZZ. Same with, let's say, version 2, when we just added 2 records, so it will just show 2 records. So you can actually trace back to the each version of your table, and this is the most important thing that is enabled on the data lake after your open table format. Bro, take it seriously, bro. Open table formats are really, really important. Okay, so now let's talk about the hard deletions, because we have seen like soft deletions. Okay, data will be there. So let's see. Let's say that in some cases we need to remove the files. And what are those scenarios? I think it is a right of a consumer. If consumer wants to remove the data from the source systems of the organization, the person can ask for this, if you do not know this. And in many countries we have this rule. So in those particular scenarios we have to remove the data. So in those particular scenarios we have to remove the data the same way we remove from data warehouses, like actual deletion. So here comes the role of very popular command, and it's called vacuum. What it will do? Vacuum. So vacuum command will just remove your unused Parquet files. Unused Parquet files. So in our scenario, 2 Parquet files are unused, right? Let me just show you if you just forgot, or if you just stop the video in between. That's why I just create like long format videos, so that you cannot stop. Just learn it in one go, bro. Just learn it in one go. And I'm trying my best to just keep you engaged throughout the video, so that you can just feel okay, you are learning. And see, focus. So basically we know that this file is cool. This file said like I have just 2 records, 1 and 2, and I do not have any kind of dates, so I am good. Then we know that this particular file 0AD added when we added ID 3 or 4. Then this was added when we just updated it. Then this was added when we just deleted a record. So basically these 2 files are being used. These 2 files are not being used. So with the help of vacuum command, we can remove all the files which are not being used by the latest version of the data. Yeah, but there's a drawback of it. You cannot go back to that particular version then. No, because you have removed the files. Bro, common sense. You are saying that you want to read this data and you have removed this data. How you will just go back to the state? But in some scenarios, we need to just do this. Okay. So can we just run vacuum command as it is, and there's no kind of precaution we have? So it will not remove all the files. It will only remove those files which are older than 7 days. Okay. Yeah, only older than 7 days. That means if your data, like in our case as well, our Parquet file are not 7 days old, right? So it will not remove this. It will not remove those files. And we can obviously change this timestamp. So basically you can simply say alter table and then table name, and maybe it's bronze dot my table 2, and then you can simply say set table properties. Oops. And in the table properties, you can just give that code that would be available in the documentation to change the vacuum timestamp. Let me just check it here. Let's explore, bro. Let's explore, because there's a like configuration that you can just add. So change vacuum time duration delta lake. Let's see. Table utility commands. Yeah. So yeah. I want to see the table properties. Retrieve. By the way, I know like how to just remove even without changing the properties, but I want you to know. Just take note of it. Okay, so let me search table. Okay, so it is saying that you can just do this. See, vacuum deletes only data files, and you can just set this duration to 30 days. And version, we have already covered this. Yeah, here it is. Just take note of it. Don't worry, we are not using this thing. Okay, so this is just saying for the create or replace table, but it is also there for like alter table. So we can simply write this. delta dot deleted file retention duration equals to 3650 days. 10 years. Okay, no, this is like too much. Okay, so obviously you can just assign it, let's say 30 days, or let's say 60 days or 90 days. Like it is fine. Till 90 days it is fine. 3650 days are like too much. Okay, so this is the thing that we can add here if we just want to change it, because let's say we want to be double sure and we do not want to remove files which are not older than 90 days. We can just simply use this. Okay, and what we can use in order to remove the files immediately, like I want to remove the file right now. So we can simply use something called as retain keyword. So I will simply say vacuum table name, first convert into SQL. Let me just make the default language a SQL. I cannot like do it again and again. Where I think view, they keep on changing the UI, man. I don't know why. Where's the default language? View default language, run, help, file. Okay, I can just change it from here. Because in Fabric notebooks, I think they have here clone rename. It should be in edit, or maybe in run. Oh man, in edit, format cells, format notebook, format indentation, add parameter, find place, help, change default. Yeah, I don't know like how I can just get this. Don't worry. Confirm. Like now my cells are like SQL. So vacuum, then I can simply use table name bronze dot my delta table 2. So this is the vacuum command that I can run. And if I just run this, nothing will happen because my files are not 7 days old, so it will not delete anything. Okay, so it will run fine, I guess, and it will not delete anything. You can still see the files. That is the kind of precaution that we have while working with vacuum command. Okay, so just for your knowledge, we have this thing. See how many jobs it needs to run. Obviously, bro, you're working with open table format, so you need to just make sure everything. But the good thing is you do not need to do anything. So now you will say, Hansh Lamba, just show us the file. We guess it is deleted. Don't you trust me? Let me show you. Go to file store, open table format, sync data, my table 2. See, all the partitions are there, all the 4. See, bro, nothing is deleted. So we can run something called as, okay, by the way, I want to tell you this as well. So basically, let's say you want to run the file, like you want to just run the vacuum command which are older than 7 days. But if you want to make sure what will be the deleted partitions, so you can simply use this dry run. Now just run this and you will see all the files which will be deleted if you run vacuum. So this is a kind of list. Hey, bro, you are going to run vacuum and these are the files which will be deleted. Do not come to me back when you delete these files. Okay, so dry run is a kind of highlight that you will see. Hey, this will be the result. So it's all up to you. So you should always see, you should always use dry run. So in our case, no files will be deleted because no file is older than 7 days. Okay, now what I will do, I will add one statement. I will simply say retain 0 hours. Now it is risky. Let me just run this, then I will explain this. You would like to vacuum command with such low? Yes, I want to. Oh yeah, basically this retain 0 hours is a very risky command. Why? Because it will remove all the files, even the files which are not 7 days old. It will remove those as well. So you cannot even go back to your previous version as well. So that is why it is a very risky command, and that is why it is giving me a warning. Hey, are you sure you would like to vacuum files with such a low retention period? You have writers that are currently writing to this table. There's a risk that you may corrupt the data. See, this is very risky command. So you should always use it with precautions. Okay, and in order to just do the see, it is saying that please use a value not less than 168 hours. And I think 168 hours equals to, I think 7 days. Yeah, I think 168 hours equals to 7 days. I don't know. Yeah. So it is saying, but it doesn't know that I want to delete. I want to delete. So there's a command that we first need to apply on this particular table, and then it will allow us to delete the data, because it is too much caring for us. And it knows like there can be some developers who are so you can say careless, and they do not even understand the risk behind these kinds of operations. So that is why we will just apply that particular command, and then we are good to go. Simply use this particular command, and it's called, let me just write it for you. So if you're just using SQL cell, then you will simply say set, and then this Spark SQL Databricks delta retention period check enable first. What it will do, it will simply remove that particular step which checks that, hey, it is removing the files, so you need to confirm. So it will just remove that step. So let me just run this first. So the moment I will just run this, then you will see my files will be coming here, that these files will be deleted, because I'm just running dry run. So I'm not actually vacuuming it. I'm just showing you what files will be deleted if I run vacuum command. So this is a precaution command that you should always run before running the vacuum command. See, the result is in front of you. It is saying that all these two partitions will be deleted, all these two Parquet files will be deleted. And now let's delete it. You will say, hey Anshlama, just show us. Okay, let me just delete it. So now it will delete the files, and then you will see there will be no partitions, no Parquet files. Really? Again, I have just shown you all the precautions. So now it's up to you how you want to use this vacuum command. This is a very rare scenario when we just run vacuum command, and we do run vacuum command, let's say on the files after, let's say, 1 year. Because if we just want to keep a track of the files for 1 year, and if we just want to go back to the data for just 1 year, then we just can set the property as if you have just saw, as you have just seen that I have just showed you how you can just change the table properties. You can simply alter the table, and then you can simply set the table properties, and you can simply change the duration. So by the way, it has removed the files. Let me just confirm. Let me just go back to the catalog. Let me just go back to a DBFS, and here you will see I just have two partitions, two Parquet files instead of 4. Successfully removed the Parquet files. Very good. So now our vacuum command is also done, and we have just seen that soft deletion, hard deletion, and how we can just take care of all those things. So now it's time to actually talk about schema enforcement and schema evolution. Schema enforcement and schema evolution. So let's say, do you remember like we just loaded the data into our location in our data frame? Let me just remind you. So this was our data frame that we read using CSV, right? And this was our data file that we stored in the sales data. And we can also see the data. See, this way we just saw the data because we didn't have any kind of table. So we just ran the SQL command on top of it. Makes sense. Okay, so let's see what will happen if we load another data file using CSV. And I have just uploaded all the 3 files. Okay, so just upload second file. Why are you smiling, guys? Because something will happen here. Okay, so what will happen? So this file second, let me just run this, and let me just show you how does it look like. Okay, so this is the file, and schema looks exactly same. So this file can go easily to this particular location, right? Let me just run this. Okay, and this file has like total 31 rows, and previous file had I think 98 rows. What happened, bro? What happened? Setting overwrite. Okay, I see. So this is not a bug, this is not an error. This is just like we need to just use mode, because it says, hey, a file is already there. How you need to merge the file? Do you want to append it? Do you want to overwrite it? Do you want to ignore it? So we will simply say, hey, append it. Okay, I will simply write this file. Okay, so now I hope it is fine. Oh, just add the backslash, syntactical error. So this is done. So let me just query the data stored in the folder. So you should see 126 rows. That means now rows are added. Now here's the thing. Here is the concept of schema enforcement and schema evolution. Now, our third file, let me just first type it for you. So our third file, let me just show you how does the schema look like. Okay, so now this file has 100 rows, but this file have this file has one more column. It's called return flag. So that means your source, let's say this is your source, this is your destination, okay, actually doesn't have the exact same schema. And in Delta Lake, in open table format, we enforce the schema similar to data warehouse. So you want to know what will happen when I will just running this query for this one, okay, it will throw me an error. Why? It will simply say, hey bro, a schema mismatch detected, and this is the error that makes sure that schema enforcement is there similar to data warehouse. Yes, okay, this part is fine. But Ansh Lamba, we just talked about that we need to use schema evolution. Yes, and you said that open table format makes it really easy to use schema evolution. Yes, so how we can just work with schema evolution? So the answer is very simple. You simply need to use one command, and it's called dot option, and then simply write merge schema, then make it true. That's it. When you will be actually running this command, it will evolve the schema. It will simply add this particular schema, and it will just add the records. Let me just do it for you. Let me just run it. So you will see it ran successfully. Okay, it ran successfully. See, and now let me just query the data, and a new column will be there. So first of all, as you can see that we have 226 records instead of just 120 something. Okay, let me drag it towards right. You can see return flag act equals to 1, and for all the previous records, what will be the value? Just a common sense, null, because we didn't have that column previously. Okay, so this is your schema evolution and schema enforcement in Delta Lake or in any open table format. Make sense? So now let's talk about the metadata level changes that we apply on the schema, or let's say on any file. And this is really important. Let's say you are a developer and you are making changes to the file that is in the Parquet file. These changes can be, let's say, if you want to just add a column, or let's say if you want to just, yeah, let's start with the add a column. Let's say if you want to add a column to your table. Okay, so in order to add a column to your file, because obviously your table is built on top of your Delta format, which is open table format. Okay, and this is a real file. So let's say you want to add a column. Okay, and this is your actual real file which is holding your data. So what will happen in these kinds of changes? Actual thing will be happening on top of this Delta log. That means if you are asking Delta format to add a column on your table, it will not add a column here in the file. Okay, it will simply add the column here in the Delta log. That means your files will be untouched and your schema will be updated, which is used to just form the which is used to just show the structured form of your data. Another example, if you just, let's say, want to reorder the column, that can be the scenario. Like you want to reorder the columns, you want ID column appear after name column. Let's say in that particular scenario, all that reordering will be done on the Delta log level, not on the file level. These are your metadata level changes, not on the file level changes. No changes will be there on the files. So let's see how we can just perform these things, because these are really cool features. Let me just show you how it actually works. Okay, so let's say I want to add a column on my table, and first of all, let me just show you the current state of my table. Okay, let's go to delta log, and we have currently JSON till 5. Okay, perfect. So let me just show you what will happen. So I will simply say alter table, and table name will be bronze dot my table 2. Okay, and I want to add a column, let's say flag, and data type is int. Perfect. Let me just run this. Okay. Oh, I need to just write add column, obviously, because I am just adding a column. So this column is added. This column is added. You want to see the results? Let me just show you the data. Okay. Select asterisk from bronze dot my table 2. Let me just show you the results. Okay, so we have this data, obviously, and we have a new column. And why we have null values? Obviously, because we do not have any value for it right now. And if we just insert some data, we can see the data. But before that, let me show you what will happen on the data side, the actual data side, the DBFS side. Okay, so if you will see, we have a new JSON, but we do not have any new Parquet file. So what happened? What happened? So basically, as I just mentioned, that these are the changes that are applied on the metadata level, on the schema level. So in this particular JSON file, we have a new updated schema for the table, but we do not have any kind of new Parquet file or any kind of new addition to the data. So that means our Parquet files are untouched, but we have this data. So let me just confirm this information, and let me just show you how our JSON, how does it look like, and where is my data frame for JSON? It is here. So let me just run for 6.json. Let me just show it to you. And yeah, perfect. So now, as you can see, so now it says that in this particular sixth log, we do not have any add or remove. No, we just have metadata. If I just click on this, I will simply see the new metadata, and new metadata has this flag column. See, this is the metadata level changes that we have made. Okay, so now if I add any data, I can add any data to this particular column, which is flag. Okay, which is flag. Okay, makes sense. And let me just do one more thing. Let's say I want to reorder this table. I want to keep ID column after name. Let me just do that. So alter table bronze dot my table 2, and I want to, oops, I just ran it because I have a habit of hitting shift plus enter to go to the next line, but here we just run it. Okay, so alter column, yes, alter column, column, alter column, and then we need to specify the name ID. Then we will simply say after name. I'm just specifying that I want my ID column after my name column. Make sense? It will do it. Let me just query my data again, and I will see my data as it is. See, name, ID, salary flag. Nothing changed, right? Let me just go to the catalog. Okay, let me just go to the DBFS. Let me just go to the delta log. We have another JSON created, but nothing changed on the file side. See, and in this new JSON, you already know the answer, like what will be there. Obviously, they have just added a new metadata. Let me just query it, and let me see how does it look like. And where is my output? Yeah, here it is. So I can simply click on this drop down. Okay, and then I can simply see ID column is coming after the name column. See, they have just renamed the metadata, like reordered the metadata. Okay, so now this is fine. These kinds of metadata level changes are fine, but there's like one or two crazy metadata level changes. For that, you need to just do some changes in your table. So let's say you want to drop a column, you want to drop flag column. You will simply say drop, or let's say alter table bronze dot my table 2, and then you will simply say drop column. drop column flag. Okay, let me just run this. So it will simply say, please enable column mapping on your delta table with mapping mode equals to name. Yes. So for this, you need to actually enable the column mapping. Still the changes will be at the metadata level, but it will ask you to enable the column mapping. So let's say you want to drop a column, or let's say even you want to rename a column, you want to enable this. And how you can just enable this? Basically, there are something called as min reader version that you need to set it to 2, and you need to say min writer version equals to 5, and you need to say mapping mode equals to by name. That's it. And for this you need to first alter the table. So you will simply say alter table your bronze dot my table 2, and then you can simply write this. I can just zoom it for you. You can just copy and paste it from here. See, minimum reader version 2, minimum writer version equals to 3. Actually it should not be 3, it should be 5, because I know it should be 5. Okay, and column mapping mode equals to by name. So when you run this, you are good to just run this thing then. See, so I'm not making any changes. I'm simply running the same thing, and it will simply run it this time. So perfect. So now, obviously, it will be having a new JSON file. See, just go here and dbfs, and obviously 8 JSON is waiting for us. See, 8 JSON, or basically 9 JSON is waiting for us. Why? Because in the 8 JSON, we just updated the table, like we just enabled the column mapping. So 9 JSON is actually holding our JSON, which is the metadata. Okay, let me just apply the rename as well. So let's say alter table bronze dot my table 2 and rename column id to customer id, let's say. Okay, let me just run it. So it will simply run it, and as you can now, you know, there will be, oh, ops, let me just click on it. I was just trying to click on catalog. So yeah, now you know, like, what will be the output. It will simply generate the 10th JSON file, right? Common sense. Now you know, now you're smart enough. See, 10th JSON, and what should be there? It should have the latest schema in which there is no flag and id is renamed to customer id. Let me just confirm it. Okay, let me just run 10.json. Perfect. I think it will fail because, yeah, I just need to remove 10 because now we have 10 JSON. Yeah, perfect. So in the metadata, we can simply see the latest data is having name, and there's no flag, and customer id is there instead of id. See, see, and it is saying that physical name is by id. That means, okay, this is interesting. This is very interesting. It is saying, if you just observe it closely, let me just zoom it. So it is saying that the name in the schema is customer id, but we do not have any customer id in the Parquet files. What do we have? We have something called as id. So it is saying, bro, you need to just use cust id, but the real column name is id, which is called as data column mapping. Data column mapping, that is why we enabled it. So enable data column mapping. So physical name is id. Physical name means physical file name in which we have that data. It is id, but we have just renamed it in the metadata level. Okay, so our Parquet file is not changed. Parquet file has the column id, but the schema is changed. That is the power of open table format, where you do not need to worry about changes on a daily basis. You do not need to change any file. No, we can directly change the metadata on the delta log level, on the transactional log level. Okay, that makes sense. That makes sense. Very good. Wow. Okay, that makes sense. Very good. So these are all the things that we have in this particular session, and let's actually now see the optimization techniques that we have within the open table format. Let me just tell you, especially in Delta Lake. So let me just tell you about the optimization techniques that we have available within the Delta Lake, or let's say open table format. So this is really, really important, because when we just work with so many Parquet files, so many files, okay, not just like Parquet files, like any files, so we need to make sure that we can optimize our tables, optimize our like destination data as well, because at the end we need to just apply fast queries on top of it, right? So we have some amazing optimization techniques available within Delta Lake. Let me just tell you, and let me just try to explain you, and you can understand everything what we have within this. So okay, so let's take an example where, let's say, in our table, okay, we have total 4 Parquet files, let's say 1, 2, 3 and 4. So these are the 4 Parquet files, and based on, let's say, data incoming in this, we have 10 records, 5 records, 3 records, 4 records. So let me just quickly write the data. So let's say here we have id equals let's say 2 comma 3, and then we have here, let's say 1 comma 4, then here we have, let's say 5 comma 7, okay, then we have, let's say here 9 comma 8. So here we have like 4 Parquet files, okay. So our Spark engine will try to just read all these Parquet files, right? Okay, makes sense. So what happens when it tries to read so many Parquet files, or let's say so many files, it is always less performant. So there's a thumb of rule that I'm going to tell you right now, that it is always good to read lesser and bigger files, okay, rather than smaller and too many files, okay, smaller and too many files. So this is a rule of thumb that you can actually note it down, okay. And performance, okay, sorted. So performance wise, this is always better. So when we have, let's say, data is coming in every 15 minutes, so obviously there will be like new Parquet files. Make sense? Because now you know everything, like how it creates a file and how it just creates the Parquet files, okay. So in every 15 minutes we will be having the new file, and our Spark engine will be trying to just go to each partition and will be just returning the results, right? Okay, makes sense. So what will happen now, we can use one optimization technique which is called as let me just write with pink. It's called optimize. Yeah, name is also optimize. So it's called optimize command. When we run optimize command on top of our table, what it will do, all the underlying files will be compacted and will be coalesced. So let's say instead of having 4 files, it will, let's say, merge these 2 files, and it will merge these 2 files. So instead of having too many files, we will just be having only fewer files with the ideal file size. So let's say it can just merge these two and it can merge these two. So instead of having 4 files, we can now have only 2 files. That's it. And how it will be done? Using optimize command. Do we need to do anything? No. It will automatically, Delta Lake will automatically decide like what should be the file size and how it needs to just coalesce the partitions. So in our example as well, in our table we have 2 Parquet files right now. If I run optimize command on top of it, it will become only one partition, because all, like, both the Parquet files are really, really small, so it will just create one. Okay, sorted. Okay, this is understood, and this was easy, and this is really, really helpful. We have another command, okay, and it's called, by the way, it is not an independent command. It can be added into optimize command. So when we add optimize and we add something called as z ordering, then we can actually boost up the process by, let's say, so many times. So what it will do, as we know, that it will just coalesce the partition, because optimize will be taking care of that thing. Okay, so it will just coalesce the partitions. Okay, 1 and 2. Okay, that makes sense. But after that, what it will do, it will simply sort the data. Okay, it will simply sort the data within the partition as well. So that means these are the two things that we have here in the partition. So here will be like 1 2 3 4. So here it will just store 1 2 3 and 4, and here it will simply store data as 5 6 7 and 8. And just for your understanding, if we would have 1 here, it would just go here automatically because it sorts the data as whole as well. So data will be sorted. Okay, data will be sorted. Why? It's called something called as data skipping. It's called data skipping. So in Z ordering, it leverages something called as, I know they're like two main terms, but these are really, really important for you. It is called statistics. Okay, or let's say column statistics. So what it does, it will simply store the statistics of first 32 columns of your table. So whatever data will be there in the first 32 columns, it will definitely store the statistics for those columns. And what can be the statistics? Min value, max value, average value. So what is the advantage of it? Let me just tell you. So what is the min value of this? 1. Okay, it will store that in this partition. Okay, 1. What is the maximum value? 4. Okay, and here what is the min value? It is 5. What is the max value? 8. Okay, so let's say a person is trying to run the query. It's called select asterisk from table. Okay, where id is equal, like id greater than, let's say 3. Okay, or let's say id greater than 4, let's say. Okay, so what will happen in this particular scenario? Instead of running the select statement on all the partitions, it will skip this partition. Why? Just look at the partition, you will get the answer. Just use your IQ. Because we have recorded something called as column statistics, and this column statistics are saying that in this partition we just have value till 4 and you want value greater than 4, so just get lost and just check the other partition. So it will simply check this partition instead of this one. So this is called data skipping. We can actually leverage something something called as data skipping using Z order. So it is like cherry on the cake when you just add your optimize command with your Z order by. That's it. So it calls the partitions, and on the top of it, it also enables data skipping. Okay, makes sense. And don't worry, I will just show you how you can just perform all those things. Okay, and whenever we just perform Z order by, we need to take care of one thing. We need to specify the column as well, because obviously only then it will just sort the data. It will only apply Z ordering based on some columns. Yes, so we can, I think, put some columns, let's say there's specific number like 6 or 8, and just make sure that whatever column you are putting in your Z order by, that column should come in the first 32 columns. Only then it will be able to just store the statistics for those columns. That is understood, but you need to just note it down. Okay, very, very, very good. And it's time to actually look at the optimize and your C order by command. We have one more command, but I will just show you after running these two commands. Okay, so let me just show you. So let me just try to show you how you can just run these commands, and let me just go back to my table. So I will simply run optimize my table name, which is bronze dot my table 2, and I will also run one command along with the Z order by. I want to perform Z ordering based on my ID column, because that makes sense, because I will be using this column in my predicate, which is used to prune your data, just to filter out some records and all. Okay, so when I just run this command, you will actually see that it will just coalesce my partitions, and it will just create a new partition consisting those both, and it will just tombstone both the partitions, and it will just save the log. Okay, by the way, ID column, oh, by the way, very good, because we just renamed the schema. It is called cust ID. Okay, I forgot. Okay, So it will simply perform the z ordering based on that particular table and column. And now let's see what is the output. Okay, it is done. It is done, right? It is done. So now let's see the output. Just go to the catalog and just go to the dbfs and just go to this. Okay. So now if you just see our KL column, like KL table is created, and earlier they just used to put this file in the main location. Now they have started this new thing like putting KL, which is your optimized data. Okay, so they just make these changes and do not feel like overwhelmed by the time you are watching, so you will see something else. Okay, so these are some of the surprises that you will be seeing in the world of data engineering if you want to become a data engineer nowadays, because it's changing like this, bro. I'm also seeing this KL column for the first time. So but it's understood, like they have just put this file or this new file which is the coalesced version of both. And in the delta log, in the latest log, what you will see that this particular 11th JSON will actually contain that information that remove these two partitions and just add this partition. I'm so sure. Let's check it. Let's check it. 11th JSON. Let's check it. Let me just run it. Okay, perfect. So it says add this column. See, path is KL and then this one. See, and then in the remove section, we will be seeing both the files should be removed. Because now we do not want these two files, we have a better version of it. We just have one file, and it is also with z ordering. That means data is sorted. Okay, obviously here we just have one packet file, so data will not be skipped. Obviously it can be skipped when we have like mid values, because it has median value as well. So it just leverages the data statistics on the first 32 columns. Just remember that, just first 32 columns, that's it. If you will just put any column which will not be in the first 32 columns, it will not capture the statistics. It will not actually perform your z ordering. No. Okay, so that was all about your two major commands. One, but what we like, we have one more command. It is very, very, very popular. It is called optimize write. Oh, okay. It is a new command. It was not there before. So let me just try to find it. Optimize write in Databricks. Basically, it's a Delta Lake feature, but it is available in all the softwares as well, which are using Delta Lake as an open table format. Okay, so I can also open this particular documentation as well, because obviously these are like same things. So I am just looking for optimize right. Yeah, I just wanted to look at this diagram because you can just understand better. Bro, when you just speak continuously, you can make these kinds of errors. Okay. These are funny, right? Okay, so basically let me just tell you what happens. This new feature in the world of open table format, specifically in Delta Lake, it says we know that we can coalesce the files once the files are written. Yes, this new feature says you can even coalesce the files before being written. What does it mean? So let's say your executors, okay, are creating these partition 1, partition 2, partition 3, partition 4, like so many partitions, right? And these are your executors in the Spark cluster. So it says instead of directly writing your partition, as it is, what we will do, our executors will talk to each other and they will just coalesce the partitions and then they will write it. Okay, see, they are just collaborating and they are just coalescing the partitions before writing it. So instead of creating individual partitions, because obviously we get the partitions based on the number of cores, and if we have just performed repartition, then we'll be getting the same number of partitions. But it says instead of just providing the partitions as it is, they can collaborate and they can coalesce the partitions before writing it. So we will by default getting lesser number of partitions. This is so cool. So quick question, it will just sum up everything. Even if we have enabled optimize write, do we need to run optimize command? Yes. You will say why? Let me just give you an example. Let's say You are just running your pipeline, running your notebook, whatever you want to run, let's say in every 15 minutes. Okay, and optimize write command is trying its best to just optimize the data, but still you are receiving at least one file. If it just coalesce all the partition to one file, still you are receiving one file in every 15 minutes, and you will be receiving almost let's say 24 into 4 equivalent to 96. So still you will be receiving 96 partitions in a day. 96 partitions in a day. Okay, so obviously you would not want that, like 96 partitions in a day. So still, when you just run optimize command at the end of the day, it will coalesce those 96 partitions into maybe let's say 10 or 15 or let's say 16 partitions. Make sense? So it is really important. So let me just tell you like how it will just create your partition. So let's say let me just go back to my notebook. Let me just first create a data frame on top of it. Okay, let me just create a data frame on top of it. So let me just say df equals spark.read.table, and table is bronze dot my table my delta table 2. Okay, let me just do that. And oops, what's wrong? Oh, PySpark, Python, because default language is SQL. Okay, so this is my df. Let me just show it. Display df. Okay, display. Okay, again PySpark. Oh man, you are just playing with me. Okay, so this is my partition. Let's say I want to just write this partition. Okay, let me just write it. And how I can just write? Simply to this location, to the table location, and I can simply copy the code. Where's the code? Yeah, here. Let me just copy the code. Okay, and let me just simply write it without optimize write. I'm just writing before like applying optimize write. Okay, I just want to show you something. So my path is my delta table 2. This is the path, right? And I do not want to apply more schema because my schema is same. Okay, and then I can simply say save. Yeah, simply save. There's no need to say save as table. So I just want to confirm my table. Yeah, my table, my delta table 2. Okay, let me just write it. Okay, so let me just write it. Let me just show you what will happen to my folder. Let me just go to catalog and dbfs. Bro, I know you will not get this much of depth of open format anywhere else. So see, this is something called as R2. What is this R2? Let me just open this. So this is the partition that we have. This is called like a kind of new partition that we have. Okay, and in KL obviously we have like this partition. So for now we do not have like much data that can be distributed among let's say number of cores. We have 2 cores, but still let's say we have like so much of big data. So obviously it will be partitioned based on the file size, let's say on based on like 128 MB. Okay, but still what it has done, it will just create like one partition. Okay, in this case, let's say in the other case we have like at least 4 to 5 partitions, 4 to 5 packet files. But instead of creating 4 to 5 packet files, we can just use this code. Obviously in this case there will be not much difference because file is just one. But in other cases when we have like so many partitions, we can simply say option, and then you can simply say uh, optimize write, and then just make it true. That's it. You can simply run this. Okay, and when you just run this, it will just create like minimum number of partitions available, or let's say minimum number of partitions possible, so that you can efficiently store your data and can leverage optimize command before writing to the destination. So in the catalog tab, let's check what do we have. And here we have something called as bh. So don't worry, they just keep doing it. So we have bh, and in this bh we have this new partition, which is this one. Okay, and if you just check the log, it will simply say add KL that we have already checked. Then it will say add R2 and then add BH. That's it. And what do we have in R2? This thing. Okay, makes sense. So This is all about your optimization techniques that we have within the Delta Lake. Okay, makes sense. Now I want to just mention something about override command. It is very important. It is very, very important. So for that, we first need to create a new destination for our table. Let's say I want to write the same data frame, this one. Where is that? Yeah, this one, to my new destination, and this destination is called as my delta table 3. Okay, and obviously we do not need to perform optimize write, so simply use this one and simply run this command. I want to show you something. Okay, so here, let me just go back to the catalog. Let's go back to dbfs, and here I will simply go to my delta table 3. Okay, so here they have written 3 pocket files. Why? Because obviously, like, it didn't have the optimize write command, so it just wrote these much of tables, and that's what I wanted to show you before optimize write command. So if I just write my table to a new destination 4, but with that command dot option optimize write, and then if I just make it true, then you will see that only one partition instead of 3, 4, whatever. Let me just confirm, because we have optimized it. Okay, in my delta table we just have one partition. See, this is optimization before writing the data. This is really cool. This is really cool. And in this table, when we didn't perform any kind of optimization, it simply wrote 3 partitions. Even those partitions are like null, but still, because we just have like 2 records. Okay, yeah, we just have 2 records. See, we just have 2 records. Df just have like three records, and it just created one partition for one record. It's up to them. So now optimize right. Let's try to actually understand optimize right. So what I was trying to do, let's say we have written this data to a destination. Okay, now what will happen? Let's say a new data frame is there, okay, with new data, and that particular data frame is totally different. Totally different. Let me just create a new data frame quickly. Okay, let me just create a new data frame, and what I will do, I will keep the column number same. By the way, it doesn't actually matter, but still. Okay, and I will simply create a new data frame, and I can simply say data equals, and I'll simply call it as, let's say, AA, which will stand for my name, and then I want to say department, which is IT, and then I will simply say company, which is ABC. Make sense? Yeah. Then my second record, or let's not go to next line, then name is BB, and then department is, let's say, HR, and then company is, let's say, XYZ. Okay, this is my data, and my schema is, I'm just creating a data frame, like just the data frame. My schema equals, I will just use DDL schema, so I will simply say name string. Okay, and then I will simply say department string, and I will simply say company string. Makes sense, right? Makes sense. Okay, now let me just create the data frame. Df new equals spark dot create data frame. F is capital or small? Let's try. Create data frame, and then I can simply provide data and my schema. Let's run this. And data, what's wrong with this, bro? Let me just try to write my data. Oh, acha, we need to just write Python. Data is not defined. Yeah, because I just renamed it, bro. So perfect, my data frame is ready. So what I'm trying to do now, I will simply write this data here, because I want to just clear you one thing, and this is really important concept. So what I will do, I will simply use df new. Okay, and I will write this data. You will simply say, hey, it will not allow you to write data because that schema is different, this schema is different. You are right. You are absolutely right. First of all, let me just show you how does it look like. Dot display. Oh man, Python. Bro, Okay, perfect. So these are just two records that I have inserted. Okay, so now we have a command called overwrite. Okay, we have a mode called overwrite. You will simply say, hey, you can just use overwrite mode and then you are good, because you can easily overwrite the data and you should be good. Really? No. Let me just run it. Let me just run it and you will see what will happen. First of all, make it Python, bro. Then just show us the difference. Okay. So yeah, it is saying schema mismatch detected when writing to the delta table. Do you know what happened? Do you know? Let me just tell you. So the thing is, yes, we have a mode called overwrite in Spark, which actually overwrites all the files and everything in the folder. But this is the open table format. In this, even you just overwrite the files, you also need to overwrite the schema as well. Otherwise, it will not accept it. This is the power of schema enforcement, but this is a very special application of it, where if you just want to overwrite the folder, you cannot. You have to use a command called dot option. It's called overwrite schema and then make it true. Then you can just run this. Now it will allow you, and you know what happens when you run this. So obviously, just go to catalog, and where we are writing in delta table 4. Okay, just go to tbfs. In delta table 4, these are two partitions. Okay, one partition is for previous version with normal df like id, name, salary, but this is the overwrite version of it, overwritten version of it. And in the delta log, you should see only two JSON logs. One is for the first one and second one is for this one. See? And why now you will say, hey, Anshlamba, stop. We are Spark developers and we know that whenever we just run the overwrite, whenever we just put the mode equals to overwrite, it overwrites the whole folder. But why it didn't remove the previous file? Why it actually didn't overwrite the whole folder? You have the answer. The answer is table data versioning and time travel. Because let's say I want to go back to my previous version, I can go that. I can just do that. I will just show you, don't worry. So that is why whenever you just use mode equals to overwrite, still it will not overwrite your table. It will not overwrite your folder. No, it will overwrite in the schema, in the metadata, in the transactional folder, in the delta log, but not actually removing the files. And if we just query this like this 001 JSON, and let me just copy the path. Okay, let me just quickly copy it and just let me query it. Spark dot read dot JSON, and then just let me paste the location, removing the dbfs and display df. Perfect. Now you will see, bro. Yeah, see, it is saying that add this new partition which is 9 to f and remove this partition. See, remove this partition, and along with that you have a new metadata as well. See, and this new metadata will be having the new columns. See, which is called name, which is called department, which is called company. Wow. So if two things that you learned just, so if you are using override command, let's say you are not changing the schema of the files, you are still just like overriding the data, your data will not be overwritten because of time travel features. Second thing you learned, if you are overwriting the data with the new schema, you need to update or override the schema as well in the delta log, otherwise it will not allow you. That's the power of schema enforcement. Okay, and you get the time travel capability still on the file level as well. Let me show you. If you simply say select asterisk from delta dot ticks, again I'm repeating it, ticks, not single quotes, and what is the location? Location is this one, right? Very good. Location is this one, and yes, you can just use version with this as well. Version as of 0. You will see something else. you will see our name, customer ID and salary. Wow. You will see name, customer ID and salary. Yes. Okay. That makes sense. And, and. In case of version 1, you will see that just new data. Just new data. So got it? If you just go here dbfs, this is your new partition and new schema, and this is the previous version and previous schema. Got it? And why did we get only one partition? Because schema override. Boom, bro. How was it? How was it? Feeling blessed after knowing all of these things in the world of open table format? Just drop a lovely comment right now in the comments. Okay? And this is not the end. Let me just tell you one more thing. What's that? Now we'll be talking about deletion vectors that we just turned off, and now let me just show you how it will just change the dynamics when we just turn on the deletion vectors. And let me first try to explain you what are deletion vectors. So basically, let's try to understand here in the slides. Okay, what are deletion vectors? So basically, we have seen that whenever we just perform, Anshlamba, just draw something. Your drawing is really good. Really? Yeah. I was a great artist of my class. Really? Yeah. I used to make apple. No, bro. I'm really good at drawing, or I was really good at drawing. So basically, what happens when we turn on the deletion vectors, because deletion vectors are turned on by default. So let's say these are your partitions, partition 1, partition 2. Okay, let's take like this example, partition 1 and partition 2. Partition 1 has ID, let's say 1 and 2. Okay, and partition this has ID 3 and 4, because I'm just taking this example because you will feel aligned with our previous examples as well. So let's say I updated my table, and I simply said update table set name equals to blah blah, where ID equals to 3. This we did, right? This was our example. I did this. What will happen? You will simply say, hey, it will just create a new partition. Okay, and it will just make the changes like 3, 4 with obviously new name, and it will simply say, hey, do not read this and read this. No, baby, no. So let me just tell you what will happen. It will simply say, hey, bro, enough. We have like rewritten so many partitions. We know Delta Lake is cheap, but let's try to save more money for the organizations. Okay, so open table format, Delta Lake, what it did, it said, hey, what was the change? You will say, hey, ID equals to 3, that's it. So it will just create a new partition. Yes, it will create the new partition, but it will only insert that data for 3. Whoa, that's it. That's it. It will not insert whole data, just 3. And in the delta log, do you know what will be the order and what will be saved there? Let me just tell you. And bro, just drop a lovely comment. Just say I love you. Yeah, I love you, bro. Okay. So what it will do, it will simply say, hey, first of all, add this partition. And I'm just talking about the latest version of JSON. Let's say 01, 02, 03, the latest one. It will simply say, let me just name it. It will be more clear to you. Partition 1, okay. Partition 2, okay. And this is partition 3. Okay, it will simply say, first of all, add partition 1 because that poor guy is not changed. Okay, then it will simply say add partition 2 as well. What? Just listen to me. Okay, basically, let me just make it more clear. So first of all, yeah, I know this is really unexpected, but still, first of all, it will simply say add partition 1. Okay, done. Then actually it will say remove partition 2. Yeah, remove, not add. I was just kidding. So it will simply say remove partition 2. Perfect. This was expected. Then it will simply say add partition 3. Okay, that's it. You will say, hey bro, this is just only 3. Where is 4? Where is 4 ID? Because this partition is removed. Okay, don't be over smart. This partition is removed by the delta log. But here is the reality. What it will do, it will add one more transaction. It will simply say add partition 2 again. What's going on? Why it removed it if it would be just added again? So the thing is, this is added, okay, this is removed, this is added, but this new partition, which is partition 2, it is re-added but with a change, with something called as deletion vector. Okay, so it creates a new folder for us called deletion vector, and what it will be doing for us, it will simply add that particular change as soft deleted. So in the partition 2, it will mark that particular ID, which is ID 3, as modified, and once it marks that as modified, it will add that information in deletion vector, and when it will be adding back that partition 2, it will use this deletion vector information as well. So it will add partition 2, yes, but it will not add this ID 3. Why? Because this is marked as modified in deletion vector. Understood? I know the answer is no. So just rewatch this part, because it's not an easy thing. Even if you understood it, just rewatch this part. Just speak what did I just said. Okay? So that means we, instead of rewriting the whole partitions again and again, we can simply leverage this partition only, which will save our lots of cost. And it performs one more operation after this. What's that? It will simply say, hey, we just performed DML. Obviously, there are like so many files. Obviously, this file, then this file, then this file. We performed so many things. Okay, after performing all the things, it will perform optimize command automatically. That's why I didn't tell about this thing in the beginning, because you would need to know optimize. So it will run optimize command automatically, and it will merge all these partitions. Basically, it will just perform callies on these files. Or in the layman language, once your thing is done, let's say this JSON is done, it will automatically run optimize command on its own. Simple. And you know the fundamentals of optimize command. It just calls the partitions. That's it. It just calls the partitions. Instead of reading from 3 files, it can simply read from 1 file, because now you are just well versed with optimize command. Got it? Now let's see how it actually behaves when we create deletion vectors. Okay, so let's try to create a new table. Okay, let me just create a new table. Create table bronze dot new table. Okay, let's give the columns quickly. Int id int, then let's say name string. Yeah, just 2 columns are enough. Okay, so obviously using delta. Okay, then location, let me just grab the location. Location can be this one. Let me just copy and paste it, and this will be my new table. Okay, perfect. Let me just create this, and we will not be turning off our deletion vector. So let me just show you what will happen. First of all, let's insert some data. Okay, insert into bronze dot new table. Okay, values, let me just insert 1, and then let's say AA, and then 2, let's say BB, then 3, let's say CC. Perfect. Let me just insert it, and we all know how many JSON will be there. Obviously 2. How many packet will be there? All obviously 1. Okay, let's confirm this. Now you're well versed, bro. Now you're pro. Now you can pro, bro. So where's my new table? Open table format, sync data, new table. Yeah, only 1 file, and in packet we have 2 JSON, 0 and 1. Perfect. So now what I will do, I will just perform an update command, and when I just perform update command, update, and we have just like one partition. Okay, so let's try to first insert one more iteration of data so that we can see multiple partitions. Okay, let me just insert one more round of data, and in this we will simply say 4, 5 and 6. Let me just insert one more file. Now we have two partitions. Okay, very good. Now I will just perform the update command on one of the partitions. And what is that particular partition? Like the new one. So we can simply go to catalog, file store, open table format, sync data, new table. Yeah, these are the two partitions. And if you remember which was the new one, so I don't know, like obviously one was older and one is new. Okay, so not a big deal. So what will happen, we know that if I update the value for 6, so it will be only updated on in one partition file instead of both, because we just have like one partition for 4, 5, 6 and one partition for 1, 2, 3. Okay, so let's try to update the value here. Update table name bronze dot new table, and then set name equals zz, where id equals 6. Make sense? Very good. Let me just run this command, and obviously without deletion vector, what you are expecting, it will create one more partition. Okay, and in the delta log it will simply say remove the previous partition and use the new one, and there will be total 2 partition used by the delta log. Okay, let me show you what will happen. In the catalog section, what I am expecting, we have 2 partitions already, we updated one, so it will just create one more partition with the changes. Okay, and this partition will be having all the records 4 and 5 and 6 as well, but 6 will be 6 will be marked as soft deleted, or let's say modified. So it will simply say add this one as well, and add first remove this one. I will just show you, wait, because I just believe in facts. Let me just talk about the facts. Okay, perfect. So what it has done, first of all, this is our new table. Okay, so what it has done, we will simply go to the delta log. Okay, and this is our 3 JSON. Let's read that, or basically we can do one more thing. Yeah, let's read like this JSON. Let me just copy the file path. Okay, and perfect, 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 perfect. So what it will do, you can simply say df equals spark.read.json, and then you can simply say 3.json, and let's try to read what's inside it. Okay, we just need to use Python. Okay, perfect. So let me just say df.display. Again, use Python. Oh bro. Okay, so it is saying that remove this partition and add this partition, but I think it has not actually turned on the deletion vector by default, because I think this community edition account is not using the latest, you can say, runtime. So I think in this particular runtime we have to enable, because what I was expecting multiple values here, but I cannot see. So let me just like actually enable it to a new table. So let's go to our new table, and let me just call it as new table 2, and let's create a new table here, because I personally think that we need to turn on the deletion vector by default, because in the latest runtimes it is auto enabled, but this runtime, this Spark cluster, this runtime I think is 12.2. Bro, I'm so sure like it should not be auto enabled in 12.2, because currently we use like 17 point something. So let's see, we can just turn it on, like not a big deal. We can simply say alter table name. We have the code here, I just copied it from here, and alter table name. Then we have bronze dot new table 2, and set table properties, and then yeah, let's try, because that's the thing, because obviously in the community edition they cannot provide you all the latest stuff. Okay, so first of all, let's try to insert 1, 2 and 3, just to be aligned with the solution that we are using. Okay, and then just apply another iteration of the data 4, 5 and 6, then just reinsert the data. Perfect. And before updating this table, let me just confirm what do we have in the catalog. So in the catalog we have In the new table 2, we have just 2 partitions. That's it. Now let's perform the, and by the way, in the JSON, how many are we expecting? 4. 0 for table creation, 1 for deletion vector enable, then 2 for your data insertion, 3 for data insertion. Let's try to actually update the command here. Let's see. Let's see. And even if it does not perform here, that means it is not eligible for this particular runtime, but I will still make you understand everything. Don't worry, because we cannot stop because of any runtime and all. I will just tell you each and everything, bro. So here, you can see the 4th JSON. Okay, and let me just check the deletion vectors runtime eligibility first. You can enable deletion vectors on data lake by setting this table property. Okay, and available in Delta Lake 2.3.0 and above. I don't know like which Delta Lake version it is using. Let me just check. It is using. Can you just get some more information, bro? Let me just check. DBR 12.2 LTS. DBR 12.2 LTS. Delta Lake version. So here we have Delta Lake. I want Delta Lake, bro. Delta Lake version. Not a big deal. I can just also show you in my upgraded Databricks workspace as well. Not a big deal. I have one upgraded Databricks workspace as well. I will just make you understand. Don't worry at all. I was just checking what is the minimum runtime support for this, because I cannot see the desired result here. So the thing is, in this as well, I was just expecting some more partitions. Why? Because I was expecting 4 partitions, because this is a partition which has the changes, but it should just also apply the callies on top of it. And in this particular JSON, it should actually show you the result. So what I'm going to do right now, I will just take you to my Databricks workspace, which will be using the latest runtime. I will just show you by performing all the things there, so you actually understand and visualize. Obviously, you have understood the concept, but I just want you to understand all the things inside, like in and out. Okay, let me just show you. So, bro, I love you so much, so that I have just opened my upgraded version of Databricks Workspace, which is paid, but I want you to learn all the things. So I thought like, let's spend some money and let me just actually help you to understand this. So this is my Azure Databricks Workspace. Okay, and in this I have just already attached my, what do you want, man? What do you want? What do you want? Let me just log in back. They are just trying their best so that I can be stopped, but I'm Ansh Lamba, bro. So basically the thing is, this is my Databricks workspace, which is almost same with some enhanced features, obviously, because this is a paid version, and I am using my Azure Data Lake for it, and this is the attached version of it, which is similar to your DBFS, Databricks file storage, or let's say HDFS, Hadoop distributed file system, which is similar to Azure. So here the point is not like understanding like how Azure is working. Okay, I'm just trying to help you to understand how deletion vectors are working. Okay, because deletion vectors are not available in your community edition, and for some reason they are not working. So that is why I'm just here to actually explain you the concept, and you should just understand the concept. It doesn't matter like if it is not available in community edition, so you will be not understanding. No. So basically, let's try to do the same thing here. Let me just increase the size. So first of all, I will just create the table here in this particular folder, and everything else is same. Obviously your location is for Azure. Okay, everything else is same. Do not look at my code, bro. So like the previous code. So I have just created the table. Okay, let me just try it, and by default it is enabled, it has already enabled the deletion vectors. Okay, so here I do not need to apply the code which is for true, like enable deletion vector true. No, it is already enabled. So I will simply insert the data 1 2 3, and then I will run another set 4 5 6. So let me just insert this as well. I want you to understand everything, bro, today in the world of open table format, everything. So this is my data. Okay, let me just show you how does it look like here. Let me just refresh my data lake, and here's the chord table. So similar to your previous scenario, we have 2 Parquet files. Now I am going to update this particular table and we should see multiple Parquet files. Okay, so as you know that this particular Parquet is the first partition. How do I know? See the timestamp. Okay, this is the second partition, this is the second Parquet file, and this is the time. So this is the second one, this is the first one, and I am updating the second partition, which is id equals to 6. So what it will do, it will simply, let me first run it. Okay, let's try to update it and you will see something magical, something magical. Okay, so what you will see, let me just show you. Let me just refresh, hold your breath. Boom, boom. First of all, what actually happened, the new entry of this particular thing, which is called deletion vector. Okay, and obviously your two Parquet files have become 4, and you know the fundamental. Let me just make it more clear. So as you know that this was your first Parquet file with id 123, this was your second Parquet file with id 456. Then we updated the data, and according to the fundamentals, this new Parquet file is actually holding only one record, which is only 6. So 4 and 5, you will say, Ansh Lamba, just talk about this. No, I will not talk about this now. So what it will do, it will simply say add this Parquet file, remove this Parquet file, add this Parquet file, and add this Parquet file again, but with this deletion vector. Let me just clarify this with the help of JSON as well. Let me just read 3.json, not 4, just 3, because in the 4 we have that callies thing. Okay, just read the third.json, and here we have the option to preview the data. Let me just click on edit. So simple. So you will see 4 things. So first of all, you will see something called as remove. Okay, removal of your second file. Okay, then it will simply say add, addition of the new Parquet file, which is just holding only one record, only the changed records. Okay, then it says add back the same record, that like the same partition file that it has just removed. See, partition file name is same, D2E9DE99. See, but this time do not add it as it is. No, just add the deletion vector as well at the end of it. So you see, now it is being added with deletion vector as well. So this deletion vector has that particular information that this record id equals 6 is modified. Okay, very good. So now the next thing is, once we have all this information, okay, let me just go back to my table. Yeah, now once we have like all this information, now it says, hey, now whenever you will be asking me to return the data, I have to read the data from these 3 files. So it by default applies the optimize command on top of your these 3 files and creates the JSON for that as well. So let me just see and look at the JSON. So it will simply say remove all the partitions, all the 3 partitions, all the Parquet files, and just add that particular partition, which is the new one, which is the optimized version. Just click on edit and you will see remove, and simply add this particular file. That's it, which is the callied version of all the files. Got it? Got it? Very good, very good, very good, very good. So see, my dedication for you, my love for you, I want you to understand everything. Let me just close my server. By the way, it is serverless, new feature of Databricks. So just close everything, then we can simply go back to our notebook. Okay, so now you have understood everything in the world of open table format, but I want to include one more thing. What? Yes, let's talk about streaming. We also perform streaming on top of open table formats, and it is really cool feature and really easy. So in order to perform streaming, obviously we should have one source table, and we can use this new table as our source table. Okay, that makes sense, because in order to perform streaming, your source and destination should both be the open table formats. So your source should also be a delta table, your destination should also be a delta table. Make sense? Make sense? Okay, very good. So how we can just do that? It is very simple. First of all, let me just show you the table. Select asterisk from bronze, that new table, or let's say my new table 2. because we should have some understanding about the source. Table not found, I think it is new table, or let's say my table, I don't know. Yeah, new table. So we have this information, right? Okay, now we want to run the streaming, we want to perform the structured streaming. Let me just write it for you. I will simply say structured streaming in open table format. In open table format. Okay. Wow. Structured streaming in open table format. So what it will do? It will simply use this table as the source, and it will just create a kind of destination, and it will run something called as streaming query. Stream query. Okay, and it will just take the data from here, and it will automatically incrementally load the data here. Yes, incrementally. That means idempotency. That means exactly once. You do not need to worry about duplicate data. No, it will not run the data again and again. Once the data is processed, it's fine. You can incrementally run the like load the data with the help of structured streaming. With the help of structured streaming in open table format, and you do not need to actually do anything. Trust me. So the structure is very simple. Let me just show you. First of all, you will just perform the read stream method. So we will simply say df equals spark dot read stream instead of, first of all, Anshlama, turn it to Python. Oh yeah. So we will use something called as spark dot read stream. Then format, and format is delta. Makes sense. Or we can also use dot table because we have a table. We can simply say bronze dot new table 2. Okay, makes sense. Makes sense. Then we need to say something called as dot option. Actually not. Yeah, actually not. We can simply say dot load, and dot load is also done. So we can simply run this. This is fine. Really? Yeah, this is fine. This query is like initiated. Not initiated, but yeah, this query is, let's say, good to start. But this will not start the streaming because of lazy evaluation. We do not have any kind of trigger. So we will just create the trigger. And what is the trigger? Your any kind of action. Okay. And one of the very famous action is write, df.write. So we'll simply say df.write stream. Ansh Lamba, I know, Python. df.write stream dot format. This is important. You need to just pick delta. Then you will simply pick something called as dot option. And here, do we need to just pick mode? I don't think so. We need to pick mode because it's always like append only. But here you just need to pick something called as checkpoint location. Dot option. What is checkpoint location? So basically, if you know checkpoint location, I think P will be small. Yeah, checkpoint location. So this location is used to just save your current state of the table, because whenever it just performs idempotency, which is exactly once, it needs to just save the state of the data. And these are the fundamentals of structured streaming. Okay, so checkpoint location, and then we can just simply provide any location, and I can pick the location from here. Yeah, perfect. So I will simply provide this location, and I will actually create a new table, and I'll simply say stream table. Okay, stream table, and within this I will create checkpoint. Simple. That makes sense. Okay, then I just need to use a trigger, and trigger will be, let's say, processing time equals 10 seconds, because it will be just running in every 10 seconds. Okay, then in order to start the query, I can simply say dot start, and obviously I just need to put the location. Otherwise, I can also use dot to table. These are two kinds of things to start the streaming. So I can simply say dot to table bronze dot let's say stream table. Makes sense? Yeah, makes sense. Stream table, and I want to save this table to this location dot option path, then this sync data, and this will be stream table. Makes sense, man. Let's run this, and if we have any errors, we can just debug it. Not a big deal. By the way, I don't think so we have any error. Okay, so see, now this streaming query is initializing. See, let me just click on this and you will actually see a graph to process your data in the real time. This is the power of streaming in open table format. And this is not just to just show you, hey, this is just working, blah, blah, blah. I will just show you the results as well. So this is the kind of dashboard that you see, and this query will be running 24/7. 24/7. Why? Because this is streaming, bro. So whenever you will be, so this is done. This was so quick. So let me just insert some data. So far we have just like 1, 2, 3, 4, 5, 6. Let me just add 7, 8, 9. Let me just add 7, 8, 9. And before running this, let me just tell you, I have just discussed that it works on exactly one's criteria, exactly one's you can say concept. So this time it will not again reread 1, 2, 3, 4, 5, 6. No, it will only read the new records which are 7, 8, 9. That's it. This is the concept of idempotency. Let me just run this and you will see the changes, the fluctuations in this graph. This is going down obviously because this was already happened. Now just you will see it is going up. Just see. See, see. So this is the power of streaming in open table format. Okay. So this will, Ansh Lamba, just show us the results first. Just show us that it will just read the new records. Okay. Okay. So let me just query the new table. Select asterisk from bronze dot new table, not new table, stream table. You will just see 9 records instead of duplicate records. See 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the power of idempotency. Idempotency. That means exactly once. That means exactly once. Okay, very good. So this is the concept of exactly once. And this is the streaming. This is the streaming. And it manages everything automatically, all the schema changes. Why? Because we have something called as delta log. Obviously, we need to write something in the source query here. If we have any kind of schema changes, then we just write ignore changes true, and then you can just ignore the changes in the source side in terms of schema changes. And obviously, if we have some schema changes on the source side, you already know we use merge schema. And this is just like very high level overview of structured streaming in open table format. Obviously, rest of the things are same that you perform in structured streaming, but this information you need to know before start working with structured streaming. And by the way, this cluster will be running because this is streaming, so you need to interrupt it, otherwise this will be keep on running. So simply click on interrupt and do not spend your cluster. Okay, so this was all about your open table format, bro. Open table format. Now I hope this video has upskilled you a lot. So just click, not just click, just drop a lovely comment, just share this video with others, and just click on the video coming on the screen, and I will see you there. And happy learning. And just quickly click on the subscribe button as well. Love you.